I will try to explain you how to write a research proposal also. So I'm hopeful that it will be useful to you. Okay, so student, I'm audible?
Yes, sir, audible.
Okay, please. Okay, thank you. So this is my journey so far. Previously, I was working as a Ph.D. scholar at the Academia Sinica, Taiwan, which is a central government institute of Taiwan. Then I got a postdoctoral fellowship as a research scientist. I was working at the Ohio State University, USA during 2009 to 2012. And then from 2012 onwards, I moved to India and I came back to the Karma Bhumi. And I started my journey at the Bhandari Science College, Subhash University. And then from 2018, I'm working as an associate professor at Department of Chemistry, Dr. Kavi Narasimha Mehta University, Junagadh. So my professional experience is about 16 years after PhD. I have 42 research papers already published. I have 3 Indian patents, more than 20 invited talks at the national international level. Already 5 students are there in PhD program. Also published 2 books for the cancer-related molecule synthesis and the developments. Also, specifically, I'm coming from the chemistry background. Those students who are in the chemistry, they know that what is the name reaction, right? So if you Google my name, this is the reaction which I have discovered. It is recognized as Su Naval rearrangement. Su is my professor, Professor Sanlong Su, with whom I was working in the Taiwan, and we together discovered a new rearrangement, and we have given the name as a Su Naval rearrangement. You can just Google this name and you will find the wonderful rearrangement from aldoxine to amines using the oxidative condition. So this is my short profile of my research. So as I told you that I'm coming from the same background where you have started your journey. I started my journey from the Kotak Science College, very famous college in Rajkot. You may be knowing, right? So I was a student from Kotak Science College, and then slowly and steadily I get the progress, and I was selected as a PhD candidate in the Taiwan, and also got the fellowship for the research scientist at Ohio State University, USA. So I just want to tell you from this slide that you will be also having a chance now, because you are going to join the PhD program. So you must target high, okay? Or you have to work hard, of course, but you must target high to get your good research profile, okay? So that's why I'm just saying that no matter whether you are coming from any university or any colleges, right? Your work, your experience, your honesty, and your dedication is very important, so which can give you a good profile in the research. So the question always arises, why research? Is this slide visible to you, friends?
Yes, sir.
Okay. Thank you. I'm just asking for every slide so that I'm sure that whatever I'm talking, you are also having the same slide. Okay. So, why research? The question is why we should do the research? Is there any benefit? Is there any special purpose? What are the
Yes.
please somebody is have their microphone on. Please keep it muted. So whenever you join your program, I'm telling you that when you join the PhD program, you must understand what you want to do. Why research? Is there any benefit? What is the benefit which I will get what is the benefit to the institute, what is the benefit to the society. After all, if your research is not useful to the society or not useful to your community, that means your research is not up to the mark. So I put the two photographs here that's showing the contribution of some tremendous development of recently in the chemistry, especially organic chemistry. The Nobel Prize winner in 2021 and Nobel Prize winners in 2022. Whenever you see these kind of people working in the specific field, right, we must get the eagerness to know that what kind of work they have done. Sometimes we ask the student who got the Nobel Prize in your field. When you are doing the research specifically, you must know. And students sometimes don't even know the name of the scientist. Actually, they are working in their field, organic chemistry or analytical chemistry or physical or geology or life science whatsoever. I'm just saying that you must have understanding what is your field and who are the best researcher in your field. So that is the first thing you have to understand, right? So when you do the research, what you are getting, we are adding the knowledge. We are adding the knowledge. Plus, we are doing the two important things. We are trying to solve the problem and we are trying to understand the nature. Because nature has its own laws. Nature has its own reactivity. If you can understand it, you can more understand if you do the research. You can solve the problem through the research. And after all these efforts, after all, your hard work will be benefited to mankind and also benefited to nature. As you know that recently, during the corona period, you know that, right? Thousands of people were affected in India and overall, of course, right? So if people have not done research, if they have not do the research in vaccine development, what we could have done, right? So ultimately, through the research, we can benefit to the mankind and of course to the nature, right? So that's why research is very important, and you must focus on how we can add the knowledge which is existing there. Now, the question is then what is research, right? So basically, when you start your research, three things you should be having in your mind. I'm hopeful this slide is visible. The hypothesis, which is why. Second is methodology, which is how. And third one is result or outcome, which is what. So any research should have three important pillars. Number one is why. Why do you want to do the research? What is the purpose? What is the objective of our research? Number two, methodology. How we are going to do this? What will be the methodology? What kind of technique we are going to use, right? So how means methodology, the experimental part. And third part is results. So you're doing some research with certain methodology, research, what kind of result you have got? What is the outcome, right? So if your research can answer all these three questions, why, how, and what, then your entire research is called the rational research. For example, every time if I ask the students, if new students are coming into the laboratory, and if you ask why you want to do the research, then always question is because my professor told me to do this, or because my family member want me to do the research. But that is not the answer of any questions. Why you want to do the research? Why means you have to find out the rationale behind your research. Then question is how to do this. Then third is what. So all these three things we are going to understand a little bit more. Okay, so let us try to understand why. What is hypothesis? Hypothesis. So hypothesis means what? So first of all, you have to identify a problem in your field. Suppose you are working in a chemistry or if you are working in a botany or zoology, first you identify a problem. Then problem means what? The problem means, suppose I am talking about chemistry, then in chemistry there is always so many requirement for developing new medicine, new drug, or new process, or sustainable process, or green process, right? So there is a problem. You have a requirement for industry, we have a requirement for society. So there is a problem. Similarly in botany, similarly in zoology, similarly in life sciences, different. Even in computer sciences, there are problems, right? Now, when you identify a problem, then you try to look for the literature. Now, very important word is literature. Nowadays, students are not doing the literature enough. So they are not aware that actually what is the problem in their field, right? So when you do the literature, you will find out that there are problems and there are solutions always already being published. That solution already given. Now you analyze the solution, you analyze the publication, you analyze the published paper and books and different journals, and you review these publications and try to find out what is the scope, right? Scope means the gap of research which need to be plugged in, right? So the gap is very important. Somebody has already done some research. Now what? What we can improve? What we can change? What we can give better solution? What kind of solution we can give it? So that is called scope. And third one, and I mean fourth one is, now you put up a hypothesis. That is called rational hypothesis. That this is the existing solution right now in the available literature. Now I want to do this, right? So there is an existing literature and there is a gap and I want to do this. For example, right now we find that in the literature there is a drug. For example, there is a molecule which has some side effect, right? So there is a drug and there is a side effect. So you want to improve the drug so that there will be less side effect or no side effect. Okay, so there is a existing knowledge, there is a drug. Now there is a scope that you can improve it. So you put out a new solution, new improvement in the existing solution. That is called hypothesis. For example, cancer is a big problem right now in our society, right? So what is problem? Problem is a disease which is rapidly happening in our society, and we have no solution so far. So cancer, the problem. Now, how to treat the cancer? What is cancer? Different types of cancers, different types of solutions, medicine available. What are the side effects, the benefits, the lifespan? All we have to think, and that is available in the literature. Now we have to analyze the literature, and we have to try and find out the gap, that how we can get better drug. For example, if you take drug in the market which is targeted for cancer, the molecule, they are not specific, right? Or sometimes you say they are less effective. So how we can make it more effective? So there is a scope for improvement. Similarly, in every field you see, you will have a scope. You have to identify the scope. Remember that if there is a no scope in your research, you can't put up hypothesis. And your hypothesis must be validated by the results also. So why is very important. So if you can understand why I want to do this, for that you have to analyze the literature, you have to review the literature, right? Student, are you getting my point?
Yes, sir.
Okay, please.
Yes, sir.
Now, is this visible? Second slide is methodology. How? Are you getting this slide?
Yes, sir.
Yes, sir.
Okay, thank you. Now, this is very important part. Sometimes you put up a hypothesis, you want to solve the problem, you find out the gap, but you have to find the appropriate methodology to solve the problem. right? For that, you have to have an experimental design in your head. You have a hypothesis that I want to make this medicine, which will be more effective and less toxic, for example. Then you have to make the appropriate methodology. Now, methodology can be partly reported in the literature or can be not reported in the literature. If sometimes some methodologies is already reported, you have to find out how can I improve this methodology also. New methodology, improved methodology, better methodology. For example, in chemistry field, if you are working in chemistry, if some people has developed through one catalyst, one process, you can use another catalyst for the same process or different process. So that means the methodology is known, but you change it for improvement, advancement, which of course should be more advantageous. Otherwise, there will be no improvement. Similarly, in life sciences, in the scientific research of all the area, if you want to have a methodology improvement, first you have to look the scope where I can improve the methodology, or what is methodology already published. You must know it, right? So you have to do the experimental design. Again, you have to do the literature review. Now you see here the literature review is different than earlier slide what I am talking. Earlier you were looking for why, I mean hypothesis, the problem. Now you are looking for literature for methodology. How can I do this? What kind of methodology I can use it, right? So this is the another type of literature review you have to do, right? And once you finalize the methodology, you have to execute that methodology in the laboratory. And again, you have to analyze the result, whether methodology you have applied, which is working or not, which is giving you the expected result or unexpected results, right? So once you find out the methodology, you have to execute it, you have to apply it, you have to create your hypothesis in the laboratory as a realization through this methodology. So methodology is another part where you have to give the answer of how. Now, third part which I'm going to talk is the result and conclusion. This is also important, which is called the answer of what, right? So why, how, and what. Now you have a hypothesis, you do the methodology to solve the problem, and now you have to analyze the result. That this is my hypothesis, this is the methodology I have applied it, but now what is the result? Remember that your result must be in line with the hypothesis, then and then your research is in correct direction. For example, if you are working in a cancer and you're trying to develop a new molecule, new drug in cancer, and you find out that whatever hypothesis you have applied, and you find that your molecule is not working in the particular disease. Instead of that, it is working for some others. It's always possibility. That means your hypothesis is not in line with the results, right? You are getting some other results, right? That means either your hypothesis is not correct or your methodology is not correct, right? So your result must be in line with the hypothesis so that you can say that, yes, my research is in correct direction. Number one, you have to find out the rationale of your research. As I said that if your why, what, and how, if they are in line, that means your research is rational. Whatever research work you are doing, it is correct. It is in the same line, same direction. Sometimes it happens that you are doing the research and you are finding the unexpected outcome. And in fact, you will see the major discovery happening in the science, they are happening due to the unexpected outcome. You know the famous story of Alexander Fleming, right? He was doing some other research and finally find out the penicillin, which is the wonderful antibiotic, right? So it is always happening that you are trying to do some research and you get the unexpected result. That is called serendipity, right? So serendipity is also another way to find out new field of the research. So this new field of the research you get from the unexpected result. You have to again think about why, what, and how. How I can improve it, how I can do better, how I can do another improvement like that. So you can develop a new area, new field of the research in your particular field of area or interest. Ultimately, I'm just telling that whatever research you are doing, it should be published. Remember this word that whatever research you are doing, it must publish. Rather than should, I'm saying that must publish. When you publish your research, then and then people will know that what kind of work you have done. Sometimes what is happening is our most of the research are remain in the thesis itself. You are not publishing. Either student don't have time or guide don't have time to publish the results. So there is no use of this kind of research which is always remain in the thesis. Your every chapter, your every finding, your every units or whatever you give the name, right? It must be published. Suppose you are doing 5-unit thesis, your every unit should have publication, research publication. Because why I'm saying, when you publish your research, you have to give the answer of why, what, and how when you write the paper, right? Then you will realize that yes, this is my hypothesis and this is the method I utilized and this is what result I have got, right? So that will give the beautiful combination and that will realize as a research paper. If you don't publish a research paper, you just write a chapter in your thesis and it will always remain there. It has no use because it is not going to benefit to the existing knowledge. If you want to if you want to add your benefits and in your part of research you want to add in the society, you must publish your research paper. Fine. Now, always I have a question. I ask the question that how we are going to find the answer of why, what, and how. Right. So first of all, you need to do the literature search, literature review. Now, how to do the literature review? Okay. How can I get the more information that what is happening in my field? See, right now you are beginners. You are just starting. I would request all the students, please listen to me carefully. I would request all the students that you have a two choice. Number one, you go in the field where your guide is working, your research supervising is working. And number two, you create your new field, new area of research. There is a two opportunity. See, if the supervisor or if your guide allow, okay, you can follow their research field, your senior research field, and you can find out more additional benefits, knowledge, and you can find out new research paper and so and so. So that means you are utilizing your established methodology, established protocol of your seniors or your supervisors, chemistry or physics or biology or whatever they are working. Another trend is you try to find out what is happening in the modern research trend, right? How can I get that? So first of all, I'm hopeful that you know this word, research publisher. We call them as a publication house. This publication house, I am hopeful you heard this word. Are you aware about this? What is publication house? Anyone can tell me? Hello? Students, anybody know what is publication house? Have you heard this word? Publication, publisher.
Yes, sir.
Okay, good. So anybody can tell me the name of publication house, one or two?
Elsewhere, Nature, Springer,
Great. Yes. So, what is publication house? Basically, publication house, the publishers, basically they are publishers. For example, if I talk into the layman language, if you look at our daily newspapers, right? They are either Sandesh or Gujarat Samachar or Akila, whatever you think about. They are publishing newspapers. Also, they are publishing some additional publication materials every Wednesday, every Sunday, and etc. Right. So this publication house, they are publishing the informations. Rather, I would say they are publishing the research information. Right. Number one. How they are publishing? They are publishing research journals. Remember, this is journals, not general. Every time you ask the student, what is research journal? They will say research journal. Journal is not the correct word. Journals. These research journals have a specific subject. Every research publisher have a list of journals. Different field, maybe chemistry, life science, or whatsoever. They have a field, right? So they have a different journals. Subject-wise, even in chemistry, there is a more specific journals of inorganic, organic, physical, analytical, and so on. Similarly, in life science, botany, zoology, specific to zoology, and so. There are numerous. There is no enough number to say here. So they are publishing research journals. Now, what is research journals? How they are publishing? These research journals available in volumes and issues. Okay, in volumes and issues, they are available as a research paper. Now you see the line. So you have to find out the research paper ultimately. To find the research paper, you have to find out the volume number and issue number in the research journals. To find out the volume and issue, you have to go to the journal. Now, to go to the journal, you have to find out the research publisher. Like one student said here that Nature, Science Direct, right? Bentham, and so on, Theme, and there are a number of publications. I am just giving some example next. So you first go for the publisher, find out the journal of your subject, then find out the volumes and issues, the past issues since the journal has started, and then you go for the research paper. Okay, so first, whenever you want to find out your research trends, modern trends, informations, you must go up to the research paper. Now, what is research paper? So this is the publisher. I told you that American Chemical Society called SAS, Bentham Science, Science Direct, Team and Villa International. There is the Indian Society also. There is every country has their society of either a different domain of the science, maybe chemistry or life science or biology, and so and so forth. Now, this research publisher, hello, please somebody put off your mic. Hello.
Sir, I have muted him. Please continue. Sorry for the inconvenience.
Okay. So these research publishers are publishing journal. Here I have given one example of chemistry journal, which is Bioorganic and Medicinal Chemistry. Now, just those students who have not yet searched too much or they are not aware about the literature, I'm sure that many of the students, they are not knowing that what is the journal and how we can find it, right? Because we are just beginning. So this is the name of the journal, and here you can see the title, Discovery of Novel Series and so and so. So this is the research paper title. At the bottom, there is a name of the authors who have published this research paper, and there is a short graphical abstract. So whenever you go to the journal, you will find the paper title, the author, and abstract and graphical abstract for particular journal. Right. So you must understand that when you go to the journal and you find the volume number or issue number and you click on the title, you will get this kind of information as a research article or research paper. Now, another example of this journal, this is published by ACS, American Chemical Society. You can see here it is written ACS publication. The journal is OPRD, Organic Process Research and Development. Specifically in chemistry, if you want to work in the future as in company or in industry in R&D, you must visit this journal every day. See, I'm telling one of the wonderful techniques or tips I'm giving you, that if you really want to do the good research in your field, you must visit the journal which is in your field, in your research, which are published in good journals. You must visit every day. And you have to see every day what kind of research they are publishing. Also, you have to do the analysis of what kind of research already published, the different research paper, right, in that journal. If that journal is 50 years old or 40 years old, doesn't matter. Okay, you try to go through whole publications and try to see what kind of chemistry or what kind of biology or geology or whatever field they are published. Okay, so it's important that every day you don't miss it. Okay, like you are checking WhatsApp and Facebook every day, you have to check your journal every day. Okay, so when you go to the journal, you have to find out the research paper. As I told you, ultimately you have to have research paper. Now, how many types of research paper are there? Is this slide visible, students?
Yes, sir.
Types of research
Yes,
paper. So, if somebody is asking that you have to do the literature, that means what you have to do? Okay. If you want to do the literature, you have to find good research article in your field. Okay. Now, these research papers are basically 5 types. Number 1 is called notes. Number 2, I will show you also some example. End of the talk, I will show you how notes looks like, how communication looks like. What is the difference between notes and communication? What is the difference between letters and full articles and so and so. But here just I am going to explain you that there are basically 5 types. Number 1 is notes. Number 2 is communications. Number 2 is letters. Then full articles and review articles. Now, what is the difference between these 4? Generally, notes and communications and letters, first 3, are short research papers. Short means 3 or 4 pages. Generally, letters and communications are usually not more than 4 pages. Very short. But of course, very important. Remember here that there are several journals which are publishing only letters and communications. They are not publishing the full articles. What is the benefit? The benefit is that sometimes you are working in your field in research and you find out a good solution. For example, in chemistry, if I am working in a one reaction, okay, and I find out a new catalyst which can do the same reaction, but a better yield, better condition. Now, the reaction is known, but catalyst is new, right? For example, I'm saying this. So what I can do, I can publish my research as letters or as a communications, because the research is significant importance, but it is not the full research, full length of the research, right? So I can publish that kind of research in communications and letters. Number 4, which is full article. Now, what is full articles? When you do the research in full depth and breadth of your field, for example, if you are doing the interdisciplinary research, which is connecting chemistry with biology, which is connecting biology with some other cells or biotechnology or nanotechnology, which is connecting to the another methodology or interdisciplinary research, you have a lot of explanation, you have a lot of data, you have a lot of hypothesis and the solutions and the results. Okay, so that kind of interdisciplinary research or the disciplinary research with full explanation, you can publish as a full articles. Now, the last is very important, review articles. Friends, remember that if you want to do a literature survey, you must be good in finding review article in your field. Remember my word, because review article is what? Review article means it is the review of literature in particular topic. Okay, suppose somebody has done research on corona since 2018 or 19, for example, 19, let's say. Okay, and if you want to know that how much research has been done so far in terms of the virus, in terms of the medicine, in terms of the spread, in terms of the mutation, etc. Right? So you have to find out a good review article published in that field, in that topic. So once you find a review article in that topic, you will get all the informations of your field, in that topic, up to certain years, maybe 5 years, 10 years, 15 years, right? Your depending on your field or depending on your subject, you can choose the review article length. For example, if you want to do the 10 years review article, if you want to do the 20 years review article, different review articles you can find out, and you will get the exact information that what kind of work has been done in this field or in this topic. Right? I will show you also that. So that is called review article. So when you want to do the literature, you must find out actually good review article in your subject. Then you can understand very well how many research paper already published. Most of the problem with student right now is that they don't know that how much work has been done and how much left. Right? It is always there. See, if you ask any student that, they know that what kind of work I want to do, but they don't know how much work has been done already. Sometimes what happens is they are doing the work in the laboratory, and after 6 months they find out that, oh, somebody has already published my work. Right? This is a common question always arises. So doing the literature is very important. For that, you have to find out the review article in your paper is very important. Until and unless you don't find the last stop where your field is now there, you cannot find out the gap. There are other ways also. You may have a question that, is this only the way we can do the literature? No. There are other ways also do the literature where you can exactly find that whether your work is published or not. Okay, that I am going to tell you. But right now, if you find out the research article, communications, full article, letters, review articles in your field, and that's how you can create a literature. I'm just telling you from my experience that every PhD student should have at least 500 research article. I'm not telling the small number, I'm telling the medium number. It should be more than that, but at least you should have 500 literature review article in your field as a PDF file. Then you have to start your research. Why I'm saying this? Because if you don't do the literature enough, you will always find it a problem. You start your work, and after a few days or a few months, somebody will give you the paper that your work is published. Okay, so please make sure that you have done enough literature before you start your topic of research. Now, once you have a research paper, how to read the research paper? Is this slide is visible to you, friends?
Yes, sir.
Yes, sir.
Or you are getting my point?
Yes, sir.
Yes, sir.
Okay. So whenever you want to read a research paper, this is the 11 point that already there in research paper. I will show you the research paper end of the talk also. So it should have title, author, author affiliations, abstract, keywords, introduction part, which has figures and schemes and structures and photographs and whatsoever, tables, etc. Result and discussion part, conclusion part, acknowledgement, experimental, and references. In any research paper, whether it is a communication or letters or a full article, you should find this at least 11 part. Okay. When you write your research paper, again, when you write your research paper, you also have to prepare this 11 part. Otherwise, your research paper is not complete. Okay. So when you start writing your research paper, you have to have all these 11 parts. Fine. Now, these title, author, affiliation, abstract, keywords, you should be aware that what kind of information there in abstract, what kind of information I should give in author, author listing, first author, corresponding author, right? Co-author, everything you need to understand. So you start reading the research paper, then you will realize that how I can read the research paper and what part giving me what. See, if you see the part number 6, which is introduction. Introduction is always the answer of why, right? Why you want to do the research. That answer you will find in the introduction. Now, result and discussion, conclusion, that is what? That is the answer of what, right? And part number 11, that is experimental, that is methodology, 10, experimental, that is the methodology part. So why, what, and how. All these three you have to put in your research paper, or you can read from the research paper. Fine. Now, when you want to do the literature survey, I told you that research article is important. Another important thing is related reviews. So you first try to find out the list of journals, or you can say your choice of journals or preferred journals in your field, right? So first you find out what kind of work you want to do, why, right? Now you find out the journal which is publishing your work, your type of work. So you make a list of journals and you visit the journals, you try to find out their review articles, their research articles, and store it and read it. Okay. First, to do the research, it is important that you try to understand the research paper. You try to find out how to get the research paper. That is the important thing, right? Without that, you are not going to start anything. Then another good thing is books. And another one very good thing I can assure you, that is a SciFinder. SciFinder is a search engine. For example, in chemistry and life science, specifically, if you want to do the literature and you want to know that whether this has been published or not, remember that in your research, you have to do the unpublished work. You have to do new work. Okay. That means whatever work you are doing should not be published anywhere, even not a part. Okay. Your entire work should be new. Okay. Maybe method or maybe all the work you whatever doing. Right. So whatever work you are doing is already published or not, right? You can find from SciFinder. SciFinder is a search engine, but I can tell you that this is not a free search engine. It takes a lot of money, of course, right? So maybe people don't have, specifically in academia or university, we may not have SciFinder access. In some university may have, but in industry, most of the larger industry or bigger industry, they have SciFinder access. So you can You can take the help of your friends or seniors and colleagues and your professor or supervisor, whoever you're talking. You can try to find out that your work is published or not from SciFinder. Similar search engine is Reaxis. Reaxis is also the similar search engine which can give you whether your research work has been published or not. In these search engines, you can search by title, you can search by topic, you can search by structure, you can search by author, you can search a lot of things, and you can find out the latest work whether has been published or not. Then PubMed and Scopus, and for patent we have USPTO, also have Indian Patent Office. So you can try to search the Western region patents or US patents or Indian Patent Office. So they are also the part of the literature if you want to search the patents. Okay. So literature survey is not only research article, it is also from, you can do from the other search engine like SciFinder and Reaxis and all this kind of search engine available. Are you getting this, students?
Yes, sir.
Fine. Now, when you do the literature survey and you've done the research, now you want to publish your manuscript. Okay. Still, I have not started the research proposal. Still, I am talking about research paper only. So you go to the journal first. You have a manuscript in your hand. Manuscript should be in usually in Word file. You prepare a manuscript. Manuscript preparation requires a lot of time. You have done the research in the laboratory. See, I'm telling a clear truth that if you are a good researcher in laboratory is not enough. You should be equally enough for writing. Because if you have good results in your laboratory, in your hand research result, I'm talking, and if you are not good writer, your research will not published in a good journal. Okay. So if you have good research data and you want to publish it, you should be a good writer as well. It is like a 50-50. Okay. You should be all-rounder. You must know the bowling as well as batting. Similarly, as an all-rounder, you must do the laboratory work. Equally important is writing manuscript. Okay, so you must have good command in the language, specifically scientific language. I'm not talking about English. I'm talking about the scientific language. How chemistry, how life science, how biology, how geology, or whatsoever topic is there, or research field is there, you must understand how to write in the manuscript. Okay, so when you want to write the manuscript, you have to first choose a journal. For which journal or in which journal you want to publish. You get the author information from the journal. You have to choose whether you want to publish as a full article or whether you want to publish as a letter or whether you want to publish as a notes or communications, etc. Okay. Then you prepare manuscript according to the journal guideline. The journal will give you the clear guideline that how you are going to prepare your manuscript, what kind of Word file you are going to use, which type of font you are going to use, what will be the margin, what kind of figure, the size of the figure, the size of the table, the size of the photographs, everything. They will give you clear instruction. So you prepare your manuscript according to your chosen journal, and then you prepare a cover letter. This is also important. Here, the cover letter describes the short story of your finding, of your research, and you address it to the journal editor. Also, you include the reviewer list also. Now, what is reviewers? The reviewer means every time journal will ask you the name of 3 reviewers which are relating to your field. Suppose you are doing work in X field, there are some people already working in that field, I mean professor or researcher, or whatever. You must know their names, that who are working there. Okay. And you have to give the name of reviewers to them. Then you prepare the graphical abstract, right? Now, You submit the manuscript, cover letter, graphical abstract, and online submission. And nowadays, no hard copy submission. Everything you have to submit online, right? Then you will get a response from the editor of the journal. I'm just giving very shortly the story, otherwise it will take a lot of time. So I'm just giving you the short highlight how your manuscript will travel. Okay, so you will get a response from the reviewers, and there will be three possibilities: that your manuscript is accepted, or it needs revision, or if it is rejected. I can tell you that in good journal, the acceptance chances is about 10 to 20%, 70 to 80% either revision or rejected. If your paper is rejected in particular journal, don't be afraid or don't be frustrated. You have to choose the another journal, okay, which is also similar type of journal which can publish your research work. So there is hundreds of journal, okay. Even if I tell you the figure, more than thousands are journals in there, more than 1,400 journal only in Scopus index. So there are thousands of journals are there. So no need to worry. But you must prepare your manuscript. As I told you earlier, that you must have good writing skills so that it can be published in good journal. Okay. And once your manuscript is accepted, your contribution is acknowledged in the field of particular research, right? And you will have a great satisfaction and great joy that yes, you have done something new in this field, right? So you must understand this sequence. Fine. Now, so this is the journey so far, which I am talking about the manuscript. So we started from what is research, hypothesis, methodology, and why, what, and how. Three part. Then how to do the literature survey, how to read the research paper, what kind of different parts are there, and how to publish the research paper. Of course, there will be other professor, they will explain you in detail that how you are going to publish research paper, but just I give you the highlight. Okay. So now let us go further and try to understand how to write a research proposal. Is this slide visible, students?
Yes, sir.
Fine. Research proposal writing is important because when you want to write for Sodh scholarship, or whether you want to write for Inspire fellowship, or whether you want to write for funding, especially to get the money from different agencies, right? We need to understand how we can write a research proposal, because in the future you also require this, right? So generally the research proposal we are writing to funding agency, right? The purpose of writing research proposal is to get the fund from different funding agencies. In India, it is UGC, of course, DST, Department of Science and Technology, SERB, Science and Engineering Research Board, and Coast, which is especially in Gujarat, right? So you have to target your funding agency, whether you want to apply in one of these funding agencies, right, as a research proposal. Now, how to write a research proposal? What kind of different parts we have? This is one slide I am trying to explain you that every research proposal has this part. These 7 parts, 7 criteria you can say. Number 1 is the title of research proposal, right? You have to give a title of your research. Number 2, origin of the proposal. That means why. I told you why you want to do the research, right? What is the problem in the society? So it is called introduction of research problem. Now you have to put the review of status of research and development in the subject. That means you have a hypothesis, you identify a problem, you find out a scope. Now you have to find out how much work already has been done. What is the status in this field? Okay. Remember that right now, remember that you are not the first one to discover something. There is always some reference. There is always some status already there. So you have to review the status, that how much work has been done in this field, right? That's what I told you, the literature survey, right? So research and development in particular field, you have to put there. That is called review of status of research and development in the subject. Here also you have to introduce the literature review, you have to find out the current status and scope and significance of your research. Then very important part is objective of proposal. Why you want to do this? Different objectives. Then how you are going to do this? That is methodology. And how much financial assistance required. And of course, reference of your related research field. Remember here, you should not copy somebody else's work. You have to maintain the ethical practice. Okay. Plagiarism, we call them as a plagiarism. You should not do the copy and paste from other research papers or other research proposals. You have to create your own research paper and own research proposal. Okay. Of course, you can use their knowledge, you can use their words, you can use their sentences in a particular way that you can write it newly. You have to write in your own words. Anyway. So this is the different parts you have to do the research, how to write a research program. Now let's try to understand that individual part. Now, title of research proposal. Number one, this title should be concise. It should be describe the objective as well as outcome of the proposal, and also you should not use the abbreviation, right? So title should be very short. It should be very informative and should include objective as well as outcome of the proposal. Okay, so here I have given the title of some of the chemistry proposal, right? For example, design, synthesis and bioactivity of quinoline derivative. So here, what I'm talking design, synthesis and bioactivity. So my objective is clear and my outcome is also clear, right? So I must include a concise objective and outcome of the research proposal title. Some other example I already put here, you can refer it later on. Now, very important part is the second part, which is origin of the proposal. Once you decided the title, you have to find out the problem of your proposal. So here you have to give the little bit introduction of your research problem. What is the problem in your field? Then its social relevance, very important. As I told you that cancer is a problem. Now it has a direct social relevance, right? So you have to describe the problem and its social relevance, how much it is going to affect with the society. If you solve the problem, how much it is going to benefit to the society, right? Then your proposal should include the improvement in current condition or status, as I told you already. And also you must put the appropriate methodology. So there are several problems, like process chemistry is a problem, synthetic methodology is also a problem, medicinal chemistry, you can find problem in there, natural products, you can find problems, right? So there are a number of ways you can find the problems. Now, review of status of research and development in the subject. As I already told you that you have a title, you know what kind of field I'm going to choose. Now you have to do the review. For review, you have to prepare 4 category or 4 different part. Introduction part of the literature survey, then what is the current status in that field, progress in the field, what is the scope, and what is the significance of your proposal. Okay, what is the importance of your proposal you have to showcase here. Now you have to write the objective. Remember that whenever you write the objective, you have to start generally with 2, TO, 2, to develop, to prepare, to extract, to do something, whatever, right? Important thing is your objective must cover your aim of the research study. For example, you want to do the research in cancer, And if you write your objective here, instead of answer something else or general, which is not good. So it should cover your aim, research study. If your research study is larger, if your proposal includes the lot of multidisciplinary research, then you can prepare or you can write individual objective for individual plan or individual topic, right? Separate objective for multidisciplinary research, right? So, for example, you want to develop a new method, you want to develop a new heterocycle, you want to extract some isolate natural product, and so and so. So that is called objective of the proposal. Now, methodology. Methodology is what? The methods, the experimental design you want to utilize in your research proposal. So you have objective clear that I want to do this. Now, how to do this? So you must apply the experimental detail, right, to showcase the problem solution. Suppose you have a 5 objective and you can put separate methodology for all objective also. Sometimes your objective can be mixed type. You can put 2 objectives together and the methodology also together, right? Here you can provide the scheme and diagram. For example, if you are working in chemistry, if you are working in biology, if you want to showcase the flow chart or diagram or the signaling pathways or this kind of information you can provide in the methodology part. And also you have to cite the references. You should always do the referencing every time, which is known. Okay, if method is known, you must cite the reference that okay, this is known and this I want to do, right? So you can include these new methods, new design, and so on. So that is called methodology. Now important part is financial assistance. So to ask the money, it should be in separate head. You have to ask the financial support in separate head. This is the general, I'm just giving the general idea of different heads. There is one head called instruments, right? In your research proposal, you want that some instrument required. You want to purchase it, okay? So you have to give here how much money will require for, this is just explanatory, okay? How much money you require for that instrument, particular instrument, or more than one instrument, okay? Then there is another part is consumables. Consumable means which is going to utilize, like chemicals and glasswares and hiring services are called consumables. Consumable means it is going to utilize, okay? So you can figure out in your field what kind of laboratory equipment you will require. Then you can, there is a third part which is called the books, journals, or subscription of particular publications or computer softwares, something like that. You can use that part to ask some money. You can also ask to some money for travel within India. Of course, this is not a tour, okay? This is for to showcase your research, okay? To present your research, right? For that you require travel money like a train ticket or so and so, okay? And contingency. Contingency means the accidental expenses, which you have not thought of, but sometimes it happens that your instrument breaks off or sometimes your important assembly breaks up, something like that. Then you require some contingency money so that you can utilize it wherever it is required. So then you have to give the total, that this is the total. For example, here I put 6 lakhs, right? And also you have to give the year-wise plan. If your research project is 3 years, then you have to give every year plan. First year plan, second year plan, and third year plan, and what kind of target you are going to achieve. Okay, so that's how the financial assistance you can ask from the research proposal. And last, you have to give the references. Now, references, what is the references you must understand, right? So you can cite the reference of books and journals, right? Then very important thing is all the reference should be in same format. Sometimes what happens is students writing the reference very arbitrary. The pattern, the format is not unique, so it's not looks good. Okay, so you have to follow the pattern of writing referencing. For example, here I have given at the bottom here. So I start with the author. You see, this is the name is author first. Then once the author list is complete, now I'm starting with the title. The title is Synthesis Evaluation. That is the title of research article. And once the title finishes, I have bold out the name of the journal. That is Journal of Medicinal Chemistry. Then 59 is the volume number. 2016 is the publication year. And 5264 to 5283, that is a page number of this research article. That means if I go to this journal and if I try to find out the volume number 59 published in the 2016 and find out this page number, I will find this paper. In this paper, they have described the synthesis and evaluation and mechanism study of novel risk compound for anti-tumor activity. Right? So that's how referencing has to be done. And that's how you have to write every time in the same manner. Now here, one thing is very important is you should always give the reference whichever is available. Do not undercite the reference or research already published. What happens is students, if they are working in their field and they find an article which is close to their work, they will not give the referencing list or they will not include that in referencing list. That is called undercite. Of course, you should not undercite any reference, no matter how close your research to the published research. Of course, there should be difference, little bit difference, no problem. If there is a little bit difference, no problem. You must cite the reference which is published already there, which is very close to your research field. Okay, so that is called under citation. Don't do the under citation. You must give credit to people who have already done some research in that field. Okay, so that is called very important referencing part. So all this part I try to explain you how to write a research proposal and how to do the referencing. So with this, I want to complete my talk of how to write an effective research paper. Now, before I close, I just want to show you the different types of research paper. So for that, I will stop this and I will start new slide. Student, are you getting my points or not?
Yes, sir.
Yes, sir.
Okay. So now I'm trying to present the screen. My hopeful it's visible to you. Is it visible?
Yes, sir.
Okay. So first I will show you this research paper which is published in the chemistry. Are you getting this JOC not? Is it visualized?
Yes, sir.
Okay. So friends, here look at this paper. Here it is published in a journal which is called Journal of Organic Chemistry, JOC. And here it is clearly written as a note, NOTE, means this is a research paper but published as a note. Okay. Here there is a title, here there is an author. Everything is there which is already known for other research paper. Okay. But here the difference is usually I told you that notes are smaller research article. For example, this one is only 4 pages. 1, 2, 3, and 4, just 4 page, right? So this is called notes, smaller research article. Of course, it is important. Remember that if it is only 4 page, that doesn't matter that this is not useful. No, this is very useful. But the results here published as a notes. This is not a broad targeted research, but a smaller topic research. Now let us see the communication. How communication look like? Is this visible, friends?
Yes, sir.
Yes, sir.
So here you can see this research paper here already written on the top, that is short communication, right? That means this paper is not a full article, it is a short research article, and also it is 5 page only. Okay, so this is also a published article. Here you have a title, you have author, you have keyword. I told you there are 11 points in any research article. You will find everything here. In every research paper, it doesn't matter whether it's article or whether it's short communication, doesn't matter. You will find everything. So introduction is there, abstract is here, right? So result discussion part is there, right? You have tables and figures and schemes are there. Conclusion is there. Experimental section is there. Acknowledgement section is there, and reference section is here. So everything is there, right? So this is called short communication, but only 4 to 5 page, maximum 5 page. Here it is about 5 page. Now let us see the another, we call them as letters. This is the letters. Is it visible, friends, from Science Direct?
Yes, sir.
Fine, thank you. So this is published in the tetrahedral letter. This I published my first rearrangement. I told you in the beginning. It is a new rearrangement found in the field of chemistry. So this is published as letters. Now you see here, the title is there, author is there, institute is there, abstract there, introduction part is there, scheme, result and discussion, right? You will give the data to their informations, conclusion, experimental part, acknowledgement part. Sometimes you can give the supplementary data which is useful for the readers, and referencing part. So here again it is only in 5 page, total page is 5, but it is called as a letters. So communications and letters are usually 4 to 5 pages. Right? Now you look at the full articles. Now I'm showing you the full articles. Is this visible, students?
Yes, sir.
Fine. So this is the publication I'm just showing. Is a Bioorganic and Medicinal Chemistry journal, which is published by Elsevier, Science Direct. So here also, now you see this result. Okay. Now this paper article, this research article, you will see the page is 12 page now, from 1264 to 1275. In any journal, any research paper, if you look at this here, this will first give you the name of the journal, volume number, publication year, and page number of this research paper. Okay, so you have to read like that. So we have a title, this is the author, then abstract. Now here just for a few minutes, for 1 minute, I just want to tell you the article history on the left hand side. This is important. Okay, just try to showing you. Can you see the article history?
Yes, sir.
Yeah, right. So you can see here, received 22nd October 2008. That means I have submitted this paper on 22nd October 2008 to the journal. Then it goes to the reviewer, 3 or 4 reviewer, which is working in your field, and they will read your paper, they will understand your paper, and they will say whether your research paper is publishable or not, whether there is a problem with this research paper or not. Okay. If there is a requirement, they can revise it. So you can see there is a revised on 8th December. That means it was submitted on October. After almost 2 months, it was revised and it was accepted in December. Okay. So you can understand that any research paper require at least 2 months. This is the minimum requirement, at least 2 months to publish from the date of submission. You submit today, you have to wait at least 2 months. If you are fortunate enough and your reviewer say yes, then you can publish. If your reviewer says no, you have to find another journal, and again you have to go for the review, and again wait for the years, and then you can publish it. Okay. So this is a continuous process. So that's, I show you that every article has the history written, that what are the different dates included with this paper. So abstract, then introduction part, then chemistry part, I mean the experimental biological discussion, different schemes, the different data I have given, the experimental in vitro, in vivo results, then very experimental detail. So here, friends, you can easily distinguish the two papers. Earlier, I show you the letter, and here I am showing the full article. Right? You can understand that the full article is having more data and more depth research. Right? It has a biology, it has a chemistry, it has a in vivo study, animal model, everything is there. Right? So that's why it is called the full article. Okay. So reference and notes. Now, when you write the reference, you can see that here every reference has the same style. You can see the author name and then journal and the publication year in bold, and then volume number and then page number. So it is a unique style for every journal. Okay. So this is about 12 pages. So this is called research, full research article. Now you see the review articles. I'm hopeful you will be understanding. Is this visible to you, friends? Review article.
Yes, sir.
Now you see the review article. This is a review article on one reaction called Bhandari reaction in chemistry. Okay. So look at the title: past, present, and future of Bhandari reaction. That means what? This author had tried to put up all the data of one reaction in this review article. Okay. This review article is of 68 pages. This review article has 68 pages. Okay. But remember that this is a compilation of data. It's kind of a compilation, aggregation of data. So, which is already published in the different journal, different research paper. But every review article should be having a specific title. For example, this title is only for Bhandari reaction, one reaction only. Similarly, you can have a different title of your interested topic. So this is a 68-page review. Now you can imagine that if you have this kind of good review article in particular your field, then you can get all the informations, the latest trends, the latest research, what has been done in your field from past to present, right? So you must find a good review article in your field. Remember that review article is also research article, right? Review article are also called research article because whatever they are writing or they are gathering the data, it has not been done earlier. Okay, it has been not published anywhere. That's why it also publishable. So this is called the review article. If you look at this, I'm just directly going to the end of this. So see here, this review article has cited 542 references, right? That means enormous work they have done to find out the research paper and compile them and aggregate them in a particular way so that they can write this review article, right? So you can also write a good review article, because to write a review, you don't need to go into the laboratory, right? You have to do it on computer. You require a good literature skill. If you can do a good literature review, you can write as a review in this field. Okay, we can talk later on if we have time somewhere. Anyway, how to write a review article. So we have notes, we have communication, we have letters, we have full articles, and we have review articles. That's how the research data is there in different journals. Okay, so you try to find out good research paper, good research review. I'm just again and again saying this thing. So with this, I want to conclude my talk. I want to say that I did try to explain what is research, what is the 3 pillars of the research, how you can do the research, how you can write a research proposal, and different kind of research papers, how you can do the literature, journals, and different parts of the research paper, and which will be useful to you in the future. I give best of luck. If you have any question, please ask me. ગુજરાતીમાં પણ પૂછી શકો હવે.
किसी को कुछ डाउट है या कुछ है तो सर को पूछ सकते हो आप. यस दीप दूधिया, प्लीज आस्क.
Sir, can you give me some information about on proceedings?
Hello, please, can you say again?
Sir, can you give me some details about on proceedings?
Yes. See, proceedings are basically published data in the conferences. Specifically, every year, or rather maybe every academic year, in generally January, February, March, you will see the most of the institute, or so many institute, they are arranging the conferences, maybe national level, maybe international level conferences. Okay, in that national conferences or international conferences, they are accepting the research paper from the presenter. Okay, suppose you register yourself as a presenter in that conference, right? And you present your research in that conference. Now, the organizer of that conference will compile all these research presentations, or you can say the research data, with title and author and abstract and whatever information they require. They choose to contact a journal and say that we want to publish this as a proceeding. Okay, so if that journal either earlier already collaborated, or they can find a new journal, and they will give you they will give all this data to them, that these are the number poster we have, these are the proceedings we want to publish as a full paper or as an abstract. Also, it can be published in the journal. That is called proceedings. Okay, I have not included here as a proceeding because journal is not publishing proceeding daily or weekly. It is on demand. Okay, if you require, you can publish the data in the form of proceeding, but here I have included only research articles which is published regularly by the journals. But conference data, conference article, conference presentation can be published as a proceedings. Is it clear?
Yes, sir. Thank you so much, sir.
Yes. Any other question, please? See, I always ask my student that if you understand everything, if you have no question, that means you didn't understand, right? I'm hopeful that it is not the case, but still, you can ask me, or if you have any problem and if you want to have a solution from me, if I can help you, you can write my email ID navalkapuriya@gmail.com. You can write to me, or you can contact Bakshi sir or Ram sir, and there are many my good friends are there in the Department of Chemistry as well as in Tolani Science College. So, if I can be helpful to you in your research or anyway, I will be very pleased to do that. Anybody else?
Sir, I think it is clear with everyone else, and it
Okay.
was a very informative lecture about how to write a research proposal and how research works. So thank you so much, sir. And
Thank
with your
you.
permission, I'd like to introduce the next speaker.
Thank you, sir. Thank you. I'm
Thank you
just
so much.
leaving. Thank you, sir.
Sure, sir. Thank you so much. Students, our next speaker is Professor Subhash Bhandari. Bhandari sir is the Dean of Faculty of Science at Krantiguru Shanti Krishna Verma Kutch University. He is also the head of the Department of Earth and Environmental Science. Sir, we welcome you.
Thank you, Ishan. Very warm good afternoon to all. And I'll be giving a talk on the multidisciplinary approach as far as planetary science is concerned. Now, why planetary science is important and why are we focusing on planetary science are one of the basic things which need to be addressed, and we have to work on that. I'll be sharing my slides now, and then we'll just work ahead with whatever I am going to present. Okay, guys, can you see my see the slides?
Yes,
Can
sir.
you see the slides?
Yes, sir.
Yeah, fine. So basically, I'll be talking on the applications of multidisciplinary science in planetary research. And what we are going to talk about is like how planetary science is useful, what are the different approaches in which one can work on, and why it is the prime time that we should also look for new research avenues as far as as far as planetary science is concerned. Now, before coming to the various avenues in which we can go ahead, first we should know why we want to study the planets. Now, as far as the planets are concerned, or planetary science is concerned, it is basically a new word, and where we have to push ourselves and to find out new places where where humans or aliens or any kind of life is surviving, and how can we find a reach to these people. And then the next question that comes into our mind is, where do we come from? Basically, where are we going to? And are we alone in the universe? Now, you all must be aware, or you must all have heard about various, you must have seen various films and all this, where there are invasion of aliens and there are aliens living on the earth. Recently, there was an article that there are many aliens living in the form of human beings. Now, these are all the questions, and there are no answers. What the planetary scientist is looking for is like, is there any life beyond Earth? Says we are not actually confirmed, or there are no confirmatory answers, but there are like we have to fill in the blanks that there is life at other places or not, because in the beyond the solar system, in the universe, there are many other stars, and in those stars there are certain things which are still holding on, and there are certain planets which are revolving around their own star, and they have all the essential needs of life that exist on Earth. Coming next is, like, in addition to the fundamental and exploratory aspirations, what we need basically is, like, Earth is a planet, and by looking at other planets we can get glimpse of Earth's past and potential future. Basically what I'm trying to say up here is, like, Earth is basically a planet that is in the solar system, and when we are looking for those solar system in the looking, we have to find out potentials and what has happened in the past, and how Earth has formed, or how Earth's processes have going on, and what is will be our future, potential future, like the way we are going on, what will be our potential future? Will Earth be the same as it is today, or will it be forming into a form like what Mars is as of now? Because what we have studied, or what the recent research have been showing is, like, there are potentials of life on Mars, but we are not confirmatory. And what may have happened, what might have can happen is, like, the life on Earth will be something, but is what we are seeing on Mars as of now. The second thing that comes into our mind is, humans are affecting Earth in a way that may threaten its long-term habitability. So what we have to find is, we have to find another planet. If we are not keeping the way, if we are moving in the way we are moving as of now, I think it will be not long that our Earth will not be a habitable place where we can stay on. So we have to look for some other places where we can transport ourselves and we can live there peacefully. That is why we have to find out some other habitable conditions, other habitable places where we can transport ourselves. And secondly, the way we are utilizing our natural resources, the way we are using all our materials, like all our metals and all, we have to, at one point of time, all this will be exhausted by us. So we have to look for other raw materials, and we have also to look for other energies through which we can sustain ourselves. And that can only be done if we keep on exploring the different planets, the different moons, the satellites of the planets, and we can bring the resources and utilize those resources from that place, and we can use it at Earth as of now. But then again, will it be viable to use all these things, and will it be cost efficient? That is another question that has to be addressed, and it may be addressed beyond this, in the future. And so, coming up next is, like, if you look into the solar system, basically I'll be talking about the solar system, and I'll be not talking about the universe, because as of now, understanding the solar system is much more important, and then we can go beyond that. So before going to the universe, I'll be starting with the solar system. Now basically what we have done is, we have divided the solar system into basically two parts. One is terrestrial and the other one is Jovian. And in the terrestrial part, we have the terrestrial planets are small, they are rocky, and they have a platform kind of structures. They are all plains, whereas the Jovian ones have a more of gaseous planets. They have the core, in the core they have gas which has been consolidated into giant masses, and then the planets have come into the present being. Now as far as the terrestrial planets are concerned, we basically focus on Mercury, Venus, Earth and Mars. And as far as the Jovian planets are concerned, we basically concentrate into, we have divided them into Jupiter, Saturn, Uranus and Neptune. Now up here, we are not taking Pluto, because it is, some of them have been, it has been categorically placed into solar system, and some have not placed in. So I'm not going to talk. And moreover, it is a tiny rocky planet, and therefore it is an anomaly. So what we are going to we are not putting it into any place like in the terrestrial or in the Jovian. We have put it aside. Coming up next is basically when we talk about the planetary neighbors, you can see the uh, photograph of the planets. Now, if you have a look at it, beyond Sun, we have Mercury, Venus, Earth, and Mars, and then we have an asteroid belt. Now, that asteroid belt separates the first four of the planets from the rest of the planets, and the first four are more of like they are having a core inside them. It is a metallic core, whereas the other ones which are beyond the asteroid belt, they are more of the gaseous compounds, and in the core we have gas, and that gas has consolidated into solid or liquid, and that has formed into the planet. Moreover, these all planets which are in the outer planets, which are also known as the outer planets, the Jovian planets, they are having a ring kind of structure also. So when there is a ring, so they have been these rings are small asteroid bodies which are revolving around these planets. Coming up next is when we talk about the terrestrial planets, that is the Mercury, Venus, Earth, and Mars. They are, in fact, the moons of Earth as well as Mars. They are all having a rocky crust. They are having a dense mantle layer, and they are very dense, having a very dense core. So that means they are they are having a magnetic field inside. They are having tectonics is related to them, and henceforth. Now, when we talk about the Jovian planets, they are much larger than what we have, like the Earth, Mercury, Venus, Earth, and Mars. They are much larger than the terrestrial planets. They are having a gaseous outer layers, mostly of hydrogen, and they are having a center that is composed of either hydrogen, and in some places they are also having nitrogen in them. And then we have they have having a very the density of these planets is less than what is the density of Earth. Now, I'm not comparing it with Mars or Venus or Mercury, but still, because Earth is the basic platform with which we can compare the other planets, because Earth is where we can see what is happening, and rest of the planets we cannot go and touch it. But what we are seeing is through either telescopes, or through the orbitals, the satellites which has been launched by us, or through the various uh, landers through which we have been able to sample them, but we cannot see them with our naked eyes. So that is why we have taken Earth as the basic point from which we can decipher. Then these all outer planets are having the ring systems which I had told you earlier. Now, coming to Mercury, Mercury is nearest to the sun. It is orbiting around the sun with having the least periods, that is 88 days, and it is the smallest of the terrestrial planet, and has a diameter and gravity that is 38% more than that of Earth. So that means when if the gravity is concerned, as far as the gravity is concerned, it is going to be much higher than what we have having at Earth. Similarly, the magnetic field of Mars is also 1% stronger than that of Earth. So that means, like, there it is more of the magnetic minerals, or it is more of the iron oriented minerals that are there on Mercury. Coming on the surface of the Mercury, like these were whatever the photographs I am showing, they are highly cratered. Now, what do you mean by cratered? I think geology people must be knowing what craters are, but as far as the other subject people students are concerned, they may be aware or they may not be aware. But basically, craters are something when a bigger object or a object that falls on a surface, it forms a ring kind of structure, and that impact brings up a whole ring kind of structure. So that is a crater. So as far as Mercury is concerned, craters are formed on Mercury, whenever huge rocks have been rocks fall on the surface of the planet, and then the rest and whatever the surface that is remaining, it is all kind of plain or smooth plains. Then as far as the temperature is concerned, it is in the daytime, since it is very near to the sun, that means in daytime it is around 400 degrees centigrade, and as far as the night time is concerned, it is minus 200 degrees centigrade. Now how come minus 200 degrees centigrade? Now that is because it is on the opposite side of the sun, and at that place there is no light that is falling, so there is a drastic difference in the daytime and the nighttime. And then because of the high temperature and the weak gravity, there is no atmosphere as far as the sun is concerned. Now when I'm talking about no atmosphere, that means there will be no life, or there cannot be any life on the surface. But then there are volcanics on volcanic systems that have been there on Mercury, and which has been also been studied. Now coming to Venus, it is called the sister planet of Earth, or it can be, we can compare it with many of the properties can be compared with that of Earth, and similar that is it but there are certain irregularities also. So that is like it is having a very weak magnetic field. It rotates from east to west, whereas the Earth rotates from west to east. Then it rotates at extremely low level, that is around once in every 243 days. So that means Venus is revolving on its own axis at around on its own axis, and it takes 143 days to come at its own at the same place, and then it takes around 225 days to orbit around the sun. That means the year on a moon on Venus is 225 days, whereas on Earth it is 365 days, or if it is a leap year, then it will be different. So as far as the surface of the Venus is concerned, we see a thick pale yellow clouds that are surrounding the Venus, and the atmosphere is because of the atmosphere that is happening, and its surface is therefore since it is having an atmosphere, we cannot see the surface of moon before before present. But now because of the satellites, or because of the satellites which we have launched from Earth to see or study Venus, we are able to find out that the surface of the moon is more of what do you call, a pale yellow or a reddish color. That is because of the sulfur that is present on the surface of the Venus. That, and it is having about 80% of the surface of the moon is of the Venus is covered with lava, and it is also having faults and fracture systems, and that indicates that there is tectonism that is still persisting on the surface of the Venus. And but as far as the volcanoes or the fractures are concerned, they are not at all we are not sure whether the tectonic activities are still occurring or still happening, because we don't have that much of ample of data on that. And that is where that is the lacuna, or that is the gap which we have to fill. And if you are going to study on all these aspects, you can find out how the systems on Venus are moving ahead or happening. And similar on these bases, maybe in coming future our Indian Satellite Research Organization, or ISRO, is going to launch one satellite which is going to revolve around Venus and take pictures of the satellite, and then it is going to analyze and find out what kind of system is going or happening on Venus. Coming up or talking about the atmosphere of Venus, it is very dense. That is, you can see that the surface is all heated, and the surface is around 460 degrees centigrade. Then we have the and it is having a atmosphere, so that because of that, it is not allowing the heat to go out of the planet, and that is why the planet is having a very high temperature of around 460 degrees centigrade and so forth. But the clouds are made of it is having the yellow color is coming from the sulfuric acid that is concentrated in the form of droplets, and it is having an atmospheric pressure of about 90 times more than that of Earth. That means if an atmospheric pressure is 90% more than what is on Earth, life will not be able to be possible to exist on Venus. Now, as far as the temperature, as I had told, it is morely of 475 degrees centigrade around. It acts like a greenhouse and trapping the heat, and it is not allowing to radiate it, and that's why the surface has been continuously hot in day or night. Now coming to Mars, uh, it is the fourth planet of the sun. It takes around 687 days to orbit around the sun. It is having half of the diameter or of the planet is half that of Earth, and its gravity is around 2/5 of the Earth. It is having a very weak magnetic field, and it is also called as the red planet because of the red soil or iron oxide that is present in the soils. Now, why Mars is one of the most important planets in the Earth system, in the solar system, beyond Earth, is because of the habitable conditions that are present on Mars. Mars is one of the most look-alike, it can be called as a look-alike of the Earth. But the only thing is, like, it is not having an atmospheric cover. So it is being continuously bombarded by the asteroid bodies, which are revolving around the between Mars and Jupiter. And that is why it is having a lot of craters. It is also having, as I'll go ahead, we can also be I'll be also talking about the various kind of life astrobiological conditions, or the life conditions that may have persisted or that may have uh, existed on Mars. I'll be talking on that. Now coming on the seasons, now since Mars is tilted alike that of the Earth, that is, it is also having an angle in which it is tilted in an angle. That is why it is also experiencing the same seasons or the same climatic conditions that have been existing on Earth. But the only reason why we cannot compare it with the Earth is, like, there is no atmosphere around Mars. Earth is having an atmosphere which is protecting it from the uh, outer bodies, but Mars is not having any atmosphere, so it has not been sorry, so it is not being it is not having any it is not being protected by any seasons. So when Mars sorry, but the only thing is, like, in on Earth, season stands for around 3 months, but it is taking around the twice as long as time as far as Earth is concerned, because it is rotating at a slow speed of what Earth is rotating. Okay. Now, as far as the temperature and atmosphere is concerned, Mars is far much cooler than what it is on Earth. And in the daytimes, it is around 27 degrees, but the nights are around minus 133 degrees. Now, why this is happening? Because there is no atmosphere that is surrounding Mars, and that is why in the night, when the sunlight cannot reach the surface of the Mars, the temperature drops down to minus 133 degrees. And similarly, what I was saying, that the atmosphere is very thin, and most of it is 95 degrees centigrade. 95% of it is carbon dioxide. So though it is forming a thin layer of a very thin layer of atmospheric pressure, but it is not efficient to escape efficient, or it is not that much pertinent that it can retain the heat, and all the heat that is it has been absorbing in the day is lost what in the night time. Now coming to the ice on the Mars, Mars is having polar ice caps. That is, if you have a look at the North Pole and South Pole of Mars, and if you want to have a look at the satellite imageries of Mars, they are easily visible through Google Earth. And you must be all aware, and you must have also seen Google Earth. Now, if on the top of that there is an icon where you can shift it from Mars to Moon to Earth, and normally what we see is Earth, but if you want to change it, you can change it to Mars also, and you can have a look at how Mars is looking like. Now Mars, as far as the poles are concerned, Mars is having caps of polar caps or ice caps on the North Pole and the South Pole, and probably they were ice covered and frozen by the carbon dioxide that is present in the system, and they are also being growing and shrinking with the seasons. And the temperature differences between the polar caps and the warm soils leads to the strong winds and dust that can be cover the entire planet. So as far as because there is a thin atmosphere, and there is temperature difference on the poles as well as on the equatorial region, that has led to the formation of winds, and that has led to the formation of dust storms on the planet. Now as far as all this concern, then as far as talking about the surface of Mars is concerned, we are having on the northern sphere, basically Mars has been divided just like Earth. It has also been divided into two portions, the northern hemisphere and the southern hemisphere. And since there is no plate movement, what we see is smooth lowland plains of volcanic activity in the northern hemisphere, and in the southern hemisphere we have highly fractured, many large craters and small channels which are indicative of water activities on Mars. Now as far as volcanoes are concerned, we have recorded one of the biggest volcano, that is Olympus Moon on Mars. And based on that Olympus Moon, it is around 500 kilometers across and 26 kilometers high. So it is around 3 times of what Everest mountain is on Earth. And similarly, uh, as far as the volcanic activities is concerned, it is also experiencing the same volcanic would have experienced the same volcanic activities. As of now, there is no volcanic activity that has been reported on the surface of the Mars. Whatever volcanoes would have existed, they have existed in the past, not in the present. Now you can see the satellite imagery wherein you can see the Olympus mountain, Olympus Mons. Now as far as the Olympus Mons is concerned, it is having a diameter of around 500 kilometers. Now you can see the enormous and the height is around 26 kilometers. So you can see the enormity of the volcano that would have happened or taken place whenever it would have existed, and based on that, how it would have deformed or formed the landscape of Mars, that is to be understood. And what people in India as well as in the uh, other parts of the world, they have been working on. Now as far as the crust is concerned, volcanoes have been formed not because of the plate motion, because there is no plate as of now that has been existing on Mars. Whatever the plate motion was existing, they are all being locked. Now as far as Earth is concerned, there is a movement of the plates, and because of the plate movement, we have the origin of the Himalayas, or the origin of the Andes, or origin of the different rocky terrains. But as far as Mars is concerned, the volcanoes, there is no plate motion, and all the plates have been locked in the southern hemisphere. And because of the locking of the plates, we don't see there is no plate motion still, and because of that, the volcanoes, because of that basic plate motions, there are no volcanoes active on the surface of the Mars as of now. But there are still some reports of of tectonic activities or minor earthquakes that have still been existing and coming on the surface of the Mars, and they are still been recorded. There have been also reporting of the movement of the rock bodies on the surface of the Mars, leading to trails and tracks of those rocks which have been studied, and why all these rocks have been moving, or why tectonics or why earthquake has been coming on the surface of the Mars. That is people are studying, and that is what more of research has to be done as far as the Mars crust is concerned. Now there are canyons, there are also canyons, canyons just like the uh, the canyon that is being existing in US, or you can also, you would have also seen the Khari Gorge. So that is a small remnant of what remnant, a small example of what has happened on Mars. Now if you look at Valles Marineris, or if you look at the photograph that is in the base of this slide, there is a single long structure that has been running from east to west. Now this single long structure is a canyon that has been formed because of the surface water that would have existed on the surface of the Mars, and that surface water has been formed, has carved out this terrain because of the melting of the ice that was there on the Mars. Now if I say ice is there, then when the atmosphere got thinned out, earlier there was a thickened atmosphere on the surface of the Mars, and there was freely flowing water. But when this this atmosphere got thinned out, what happened is the whole of the sunlight that started falling on the planet, and because of the water, because of that, the ice got melted, and then this canyon would have formed. Now comes the major question, that is life on Mars. Now, because as we are saying, there is existence of water, there is existence of a thick atmospheric cover. So there are maybe also, there can be also, and we have evidences of liquid water that is present. Then there can be existence of primitive life at some time on Mars. Then if there is existence of life, what kind of life, how it was surviving on the planet, these all questions need to be answered, and this is all what we can do in our research, or we can always advise other persons to work on the life of Mars, or the work on the water activity that has existed on the Mars, or the formation of the landscape of Mars. These are some of the questions which can always be worked on and for future research. Now, as far as the outer planets are concerned, what we have is Jupiter, Saturn, Uranus, and Neptune. I'm not taking out Pluto because it is again having a rocky crust. So these all planets, the outer planets, are having an inner core as more of the gas, and these gases are either consolidated into liquid or into solids. So what we have, these are, what we say is, these are all gaseous planets, and then these are all the Jovian planets. These are all having a much larger diameter than what the terrestrial planets were having. They are having a very large diameter. They are all very large planets, and then they don't have a solid surface. What you see on these planets is they have not having a solid surface. They're all more of a gaseous kind of atmosphere, a gaseous kind of surfaces on that planet, and they are mainly composed of light elements like hydrogen and helium, not like the terrestrial planets, which are having majority of iron, silica. Then we have oxygen and carbon dioxide and all those. Now, as far as these planets are concerned, if we cut these planets into half, what we see in the core, we have more of the hydrogen components, and then we have then again metallic hydrogen, we have liquid hydrogen, we have gaseous hydrogen, we have visible clouds. So there is no you cannot see any hard rock material. They're all composed of different components of hydrogen that is concerned as far as Jupiter and Saturn are concerned. Now, when we talk about the Uranus and Neptune, what we have at the core, we have methane, ammonia, water, again no solids. The core is basically of rocks and metals, which is again more of the liquid kind of stuff. And then we have gaseous hydrogen, and again on the top we have visible cloud. So as far as these planets are concerned, they are all made of gaseous materials and nothing else. Now these all planets are having a ring kind of system. Now these rings are basically the remnants or the other what do you call particles which have been independently orbiting around these planets, and they are forming a like rings or rings which are all orbiting around. And then they are even these rings are closer to the moons also, so they are also affecting and targeting the moons of these planets. And these rings are over the planet's equator. So basically where these rings are in the middle of the these planets. Now as far as the magnetic field of Jupiter is concerned, it is the strongest one, and because of this magnetic field what we see the brilliant auroras. Now you must have all seen some photographs that that had recently come out from Greenland and even from the Himalayas, where we could see magnificent coloring formations of green color or pink color and all those things. Now these are all auroras, and they are being formed because of the solar winds and the magnetic fields that between the Jupiter and the sun, and because of that we are seeing those magnificent colors. Now coming to the research areas where one can work on are many, but as far as I have chalked out some of them, like exoplanets, planetary atmosphere, planetary formations, planetary habitability, planetary magnetism, then planetary materials, planetary surfaces, remote sensing, planetary exploration engineering. Now these are all the themes on which one can say like these are the multidisciplinary approaches where one can work on as far as the planetary science is concerned. Now as far as the exoplanets are concerned, exoplanets are the planets that have been orbiting around the these are the extrasolar planets basically, and we have been more interested in these planets because they are having the same kind of, they are revolving around the sun just like or they are revolving around the star, their particular star, just like the earth is revolving around the sun. And they are also placed at that strategical point where they are having also an atmosphere, and they are also having the same kind of system what earth is having as of now. Now if they are having the same kind of setup, they are having the same kind of atmosphere, they are having the same kind of temperature and all, that means that they are also having the same kind, they can also have some terrestrial life on these planets. And that is why we are more happy, or astronomers are more happy to discover these planets. So this is what is exoplanet, and basically how we are going to study these are all being studied through the telescopes or through the satellites which have been launched from earth into the atmosphere or into the universe, and then they are sending their photographs and we are seeing all these things, and that is how we are working on. Now coming to the planetary atmosphere. Now planetary atmosphere is concerned, it is one like all the planets are having a gaseous environment around them. Now it is this gaseous environment that is impenetrable, or these gaseous environment are saving the planet from the extraterrestrial bombardments or the bombardments of the meteors or the bombardments of the asteroids. Now if we study the atmosphere, what we are going, like just like the atmosphere of the earth, we can see how the climate and the geochemical cycles have been working on the planets or that particular planet, and whether that whatever the atmosphere is there, is that making the planet hospitable to live or not. That is also some of the questions which we are trying to answer. Now what we are studying in this is the dynamics of the atmosphere, the structure of the atmosphere, the chemical composition of the atmosphere, the planetary, and based on these studies, what we are trying to find out is the planetary formation, the evolution, and the habitability. Now, if these all the conditions are conducive for the habitability or for the sustainability of life on Earth, then same kind of atmosphere should be present. If it is present on other planets, then they can also host life, and they are also habitable. So for some creatures or some other creature, some of the life form. Now, the next question is the formation of the planets. Now, as far as Earth is concerned, we all know how Earth has formed, and that has derived from how it has been derived. It has been basically derived from the asteroids that or from the meteor showers which have been falling on the Earth. Now, those meteorites are basically being studied by the scientists, and how these meteorites have formed, and based on those meteorites, one can find out how the planets, or how the different planets on the various in the solar system had basically formed. Now, planets form a disk or dust, disk of dust and gas around a young growing star. And in recent years, new capabilities in astronomy, from detection of exoplanetary system to detailed observation of the disk around the young stars, have readily improved our understanding of the physics and chemistry of the planets. Now, basically, what we basically need is to understand what is the physics, or what is the chemistry, how these planets have formed. And they have been basically formed because we can only know, or we can only understand how the planet formation is being derived, is based on the meteorites that have been falling on the Earth's surface. Now, coming to the magnetism, we all are being affected by the magnetism, and we all know, like, Earth is having its own magnetic field, Moon is having its own magnetic field, Mars is having its own magnetic field, all the planets having their own magnetic field. And based on those magnetic fields, and how these magnetic fields have moved from one place to another, and how the planets have been behaving because of this magnetic field, can be related to the processes such as heating, exposure of high pressure and hydrothermal activities, and how the reset of the magnetism within the rocks can be investigated through the impact cratering process. Now, we all know, like, you must have all studied also, that there are impact craters, like the Lunar impact crater, or the Chicxulub impact crater, which led to the mass extinction on the Earth, or recently there has been discovery of the Luna impact crater. Now, all these impact craters, when the meteoric shower has been is there, and because of that, these rocks have been falling on the Earth and forming those craters. Now, they would have affected the magnetic field of the Earth, and how it has been reset again. That is the questions which need to be answered, and that is one of the primary fields where one can work on. Now, as far as the planetary materials are concerned, now the material basically stands for the rocks, or the sand, or the metals that have been existing on the Earth, or on the planets, or on the different solar planets of our solar system. Now, these minerals can, like, as far as Earth is concerned, the interior, basically these minerals have been forming in the interior of the planet. And when we dig out all these materials, and we try to know out how they have been forming. Now, the same minerals, if they are being found on the planets of other planets, we can correlate, and we can find out what kind of history would have existed, or what kind of history would have existed in the formation of the other planets in the planetary system. And based on this, what we need to know is, and how we can know is, that is through extremely high pressure experiments. We can know this through numerical modeling. We can know through lab analysis. of meteorites. Again, meteorites are one of the most or important or primary material through which we can study and study the formation of the planets, as well as the formation of the different metals or the minerals that have been forming on the Earth. Now coming to the planetary surface. Now, as far as planetary surface is concerned, there is being, like, if you look on the surface of moon, or if you look on the surface of Earth, or if you look on the surface of Mars or any other planet, there have been processes interesting. There have been interesting processes that have been taking place on the surface, as well as there have been processes that have been taking below the surface, and there have been processes that have been taking on the in the atmosphere. Now, if we juxtapose all these activities into one box, we can find out how the planetary bodies, or how the surface of the planet has been forming. Now, there have been that means lithospheric, atmospheric, hydrologic, and biologic. Now, we can keep aside biologic because at all places there is no biological activity, but definitely there has been lithospheric and atmospheric activities, and in some planets hydrologic activities, like, or on some satellites like moon, there are being reporting of hydrologic activities that has been taking place. Now, as far as external activities are concerned, there are space weathering and impact cratering over the geological time scale. Now, as far as impact cratering is concerned, what I told you, like, there have been discoveries of various craters on Earth, and they have been related to the extinction of the species. So it is again one of the major studies which can be taken out. Now, again, there has been formation of ancient delta systems on Mars that has been studied. There have been reporting of hydrocarbon dunes on Titan. Titan is a satellite of Saturn, and then there have been studies on the planetary landscapes and rocks, offer records to geological, climatic, and habitability histories of the bodies. Now, how are we going to study these? Now, basically, what we need is planetary exploration that is being done through satellites and remote sensing, and then we need analog field work, and then theoretical and theoretical, numerical, and lab modeling. Now, we have done some extraterrestrial Martian analog studies in Indian subcontinent that has been reported, and some of these exercises have been done at Kutch University. They have been identified through Kutch University, like the Kutch Basin. Now, you all know, like, Kutch Basin, the Jarosite locality of Matanumad. Then there has been Dhinodar volcanic plug. Then there has been Luna impact crater. Then there has been the saline flatland of Run. Now, these are some of the analogs which have been studied at up here, and they have based on the activities that has been happening on the planet on at these places, or how these would have formed these. We have correlated these sites with the surfaces or surface processes on Mars, and we have been able to correlate them. Similarly, we have there is a place called Alaldari Valley in Maharashtra. Now, it is again an analog of the valley formation on Mars. And then we have Himalayan analogs of Ladakh and Himachal Pradesh and Satluj, wherein we have found U-shaped valleys, and same kind of U-shaped valleys have been identified on the surface of the Mars. And based on that, we can easily correlate the glacial activity on Mars. Now, this is how we have been studying the analog studies, the Martian analogs, and similarly, there have been other analogs which have been observed from various other parts of the Earth, and they have been set aside compared with that of the Martian surface, and we have correlated as to the same kind of processes have happened on Mars also. Now again, then comes the remote sensing, and in remote sensing we have the radar and the spectroscopy. Now as far as spectroscopy is concerned or radar is concerned, we have what do you call that, infrared spectroscopies, and then we have shortwave and visible infrared spectroscopies. And based on these spectroscopy, we have tried to correlate the specimens, because basically we cannot go to other planets or we cannot reach them. But what we can do is we can send our satellites, and based on the satellites we can send we can get the readings of whatever we are studying. And these readings can be compared from the data library of the earth, satellites of the earth, and based on that we can compare and we can achieve whatever system that has been existing on that planet, as well as on comparing with whatever have happened on the planet earth. And this is what we have been doing. Now as far as based on these spectroscopy, we can we can identify the mineralogy of the planetaries, different planets. We can do the similarly we can also do these spectroscopic analysis for the extrasolar planets, or the planets which are beyond the solar system. Now coming to the planet habitability, as I was saying, there is there has been the surface of the Mars, or the clouds of the Venus have been can be compared to the surfaces of the Earth. And because of this comparability, the multitude, the environment, we can compare the environment as to how, what kind of environment has been existing. Now as far as the studies that has been done, we are able to find out water or water related minerals on Mars. And these water related materials or minerals, whichever has been identified, now if water is there, then definitely there are certain places that life might have existed on that place. And as life has existed because of the water, water is the basic source for habitability of a life system. And if water is there, there is definitely availability of life, or there can be availability of life. Now if we compare, we have compared such we have also done such kind of studies, spectroscopic studies now have been compared, have been done on the Puga hot springs of Ladakh. And as these Puga hot springs, or the hot springs, are one of the primary source of life. Now these Puga hot springs have been showing signals, or they have been showing deposits of chlorides and opaline silicas. And same kind of chlorides and opaline silicas have also been found on the surface of the Mars. And we know that primary life existed around these hot springs. And we are also we have also known that chloride and opaline silica are found on Mars, and we have also known that they have also been found on Earth. Now if these two have been found at the same places, then what is happening? That means in the past water was there on Mars. And if water was there, that means life might have existed on Mars. No doubt it can be a very primary or primitive kind of life, but definitely it should have, or it would have existed on the surface of the Mars. Now based on the spectroscopic studies, we could find minerals, sodium borate minerals, we could find hydrosulfate minerals, we could find and we could find opaline silicas in the Puga Valley. And same kind of minerals have also been reported through the rovers and orbiters of that have been operating on the Mars, and we can relate them with the same kind of uh, life that could have existed on Mars and same localities. Now coming to the planetary exploration engineering. Now all these things cannot happen without engineers, and basically these engineers are some persons who have been designing various satellites, who have been designing various rovers, who have been designing various orbiters which have been revolving around various planets in the solar system. It can be moon, it can be moon, it can be Mars, it can be Venus. It can, in fact, now we are even sending satellites to study the surface of the sun. Now, if and who are manufacturing them? They are all being manufactured by the engineers. So that is at the end of all this explaining all these things, I would like to say, like, it is study of the planetary sciences is not a study of a geologist or a study of a chemist or a study of a physicist or the study of an astronomical person. It is an amalgamation of all the subjects, and all the people have to come together, and they are coming together, and we are getting some good results. So with this, I'd like to end my talk. Thank you all. And if anybody is having any questions, they can ask. I think there is no questions. Nobody is asking anything. So we'll stop the session and I'll stop the sharing. Thank you so much, all.
Good evening, students. Our last session for today is by Dr. Seema Sharma. Dr. Sharma is an assistant professor at the Department of Earth and Environmental Science at Kutch University, and we welcome Dr. Seema Sharma.
Thank you, Ishan. Ishan, I hope there is no infinity mirror, right?
No, ma'am, it's clear. The presentation is clear.
Okay, and is it in presentation mode? No, it is not.
No, ma'am, it is not.
Okay, so good morning, good evening, students. In fact, I was supposed to present in the morning, so it has been evening now. And hope you are doing well. Ishan, how many students? I'm expecting 21 students here, right?
Yes, ma'am. A total of, we have 30 students from the science faculty, from geology, earth science, chemistry, and all of the science background.
Okay, wonderful. Thank you, Ishana. So students, I welcome you all in this session. It is the last session, and you have had many sessions in the entire past few weeks. And I'll try to make it minimalistic. I'll try to make it interesting so that you don't get dozed off, because being the last session, I have a lot of responsibility on my shoulders. The specific one being that you do not doze off. So the title that has been given to me to present today is Writing High Impact Research Papers in Scientific Disciplines. Could any one of you make at least the presence noise that we are here? Jalpa, are you there?
Yes, ma'am.
Okay, Jalpa, thank you. You know, speaking to screens is sometimes quite it sometimes make you feel that you're speaking to the walls. So in between, if there are any questions, if you have any queries, or if you feel that this is not understood by you, kindly raise your hand, or there's an option to raise the hand. Now you all must have become impromptu with all these symbols, but you can unmute. Ishan, they can unmute themselves, isn't it?
Yes, ma'am, they can.
Okay, perfect. So we are good to go. Ishan, just in case my voice goes away, just let me know. Huh?
Sure, ma'am, I'll do that.
Okay, Ishan. So writing high impact research papers in scientific disciplines. Now, I have been given this responsibility, taking into consideration maybe what I have been doing in this department. I'm an assistant professor here, was a scientist in the same department earlier, under the women scientist scheme of the DST, and later on a postdoc fellow in the same department. And in that lieu, I have been able to come out with certain publications that I can call the feather in the cap of this department. क्योंकि हम बात करने जा रहे हैं इम्पैक्ट की, तो पहले थोड़ा सा वी विल ट्राई टू अंडरस्टैंड कि व्हेन वी टॉक अबाउट इम्पैक्ट इन टर्म्स ऑफ साइंटिफिक डिसिप्लिन, व्हाट डज दैट मीन? Impact is not one thing, it is many things. First of all, now this can be an academic impact, which refers to the implications of research for other researchers. Now, how do we measure it? We measure it by citations, which is like, if I have done something very extraordinary, I get it published, and one of my colleague is able to cite the same work in his research, then I will call it an academic impact. As easy as that. Then the second one is impact in teaching. This can be at any level. We are talking about the PG because our department is a PG department. Why it is so important that impact of research can happen in teaching also? Because whatever we do here in our labs, I'm talking about my department time and again, because this is a very live example of, because many of you are joining our department and the life science department in other colleges, but many of you will be visiting this department on and off again. So whenever I refer to the department, it is our department of Earth Environmental Science as of now. So we should not forget that impact in teaching is very important, because whatever research that we are doing, it generally should reach the classroom and students who can benefit from this research. As an example, even if a simple academic research is done in the laboratory regarding the water quality of the X Taluka in Kutch district. Now, why it should reach the students at PG level? Because when they go through this type of research, they understand that, okay, this is this, and maybe we can add this to this, or maybe we can subtract this from this and get something out of this. So whenever you are doing any research, or as a scientist or a researcher, it has to reach the classrooms also, apart from its academic impact. The last one is external engagement. There are many things that can be called as impact. Here we are focusing only on 3. The last one is external engagement. Now, what is it?
Ma'am, did you change the slide? It's not set.
1 minute. What slide can you see, Parmar? Ishan?
Now second slide.
Yeah. Okay.
Impact can mean many things.
Okay, perfect. So maybe earlier it wasn't there. Anyways, so we were talking about the impact. Multifaceted होते हैं impacts. हमने academic impact की बात की. उसके बाद हमने बात की teaching में कैसे impact होता है. And the final one is external engagement. Now, for me, as a researcher or as a writer of some papers, I always feel that external engagement is the most important part of any research, because if any research is dying its death in the paper itself, not reaching the end users, it has no use. So it may be the policy makers who should read your research. It may be the local people who will benefit from it. As an example, we will keep talking about examples so that it becomes easier for different discipline people who are here to understand how their research can get into external engagement. As an example, if somebody has worked on certain kind of XYZ bacteria that has some implications in the field of agriculture, if it is not reaching the farmers, for me as a layman and as a researcher both, it holds any importance to me? No. Why? Because ultimately it should be the lab to land transfer, which we call it in the scientific jargon as the lab to land transfer. It should reach the end users. So the third one is external engagement. The third slide is now visible, Ishan. If I'm moving through the slides now, it is visible, correct?
Yes, ma'am.
Okay, somebody had a question, so I just confirmed it. Now, we always, because we all are here from life science, geology, we always feel that, we are working on many aspects and we are going to save lives because medical people are working to save lives. But social scientists also, they may not necessarily save as life scientists may be doing, but they can definitely improve people's lives in many, many, many aspects. We will not go into those details, but a kind of symbiotic relationship should exist between the scientists from life science or any other science as well as the social science people. Now you can see a pie chart. We are trying to understand the graphical representation of the top 100 most cited list showing breakdown by subject. Why am I again and again saying citation word or the impact? Because the research that has got citations, the research that has got the ability to reach the end users, and the research that is being used in the classroom teaching is the research that is called as the impactful research. Now here we are seeing the pie chart that the graphical representation is showing that biology lab technique papers, they dominate the top 100 list, which means most of the cited publications that you will come across when you go through your review of literature will be from biology lab technique. And the last one, unfortunately, is the psychology, and above that is just on a marginal level is physics. People are not taking very basic sciences into their research. That's unfortunate for our country. But yes, biology lab technique, many people will be happy to understand this because they are now going into biology lab technique. I'll just talk a brief thing about the top 3 most cited papers here. The first one stands out quite clear, that was published in 1951, was from the Journal of Biological Chemistry. It was about protein measurement with certain kind of reagent because it is a biology lab technique. See, there is a technique that was developed by the authors and it has till date got 3 lakh citations, about 3 lakh. And the next one has got around 2 lakh and the last one has got around 1.5 lakhs. So these are, if you can just see, these are generally the methodology papers where a method was developed by a certain scientist and it was able to make it place in respected journals like Nature. Now let us understand what we are going to, when we write papers, so how can I write high impact research papers? First, पहले समझ लेते हैं कि होता क्या है high impact research paper. Papers that are frequently cited and published in prestigious journals. As a scientist आप ये बोलेंगे जिनका citation बहुत अच्छा है और जो एक peer reviewed prestigious journal में छपा है, जैसे कि नेचर, साइंस, लैंडसेट. उसकी कैरेक्टरिस्टिक क्या होंगे? नोवेल्टी डेफिनेटली होनी चाहिए, रिगर यस ऑफ कोर्स, क्लैरिटी, सबसे इंपॉर्टेंट ब्रॉड रेलेवेंस. कोई भी ऐसा पेपर आप देखेंगे जिसको एक मेडिकल साइंस का बंदा भी पढ़ सकता है और एक normal one, somebody who is working in the lab regarding the microbes or somebody working in the soil can relate to it. For example, estimation of certain thing, such papers get lot of citations. Here I have just taken a screenshot to tell you how these most cited papers look like. Look like से मेरा मतलब है कि how, what kind of papers will you expect? Oh, these are the ones that have made a mark in the entire jargon of scientific writing. So this is one paper which was published by Lauren et al. And it is talking about the esophagitis, which is from the medical field, and it was published in the journal called Esophagus. So now this article was able to collect many citations because it was breakthrough in certain kind of maintenance and healing techniques that are related to esophagitis, which is one of the medical terminology. I will not go into the details of that. Another one, I will always be happy to share this. This is a publication from our department. Me and my colleagues have written it, and it is having a lot of citations. Today, it is having citations around more than 2100, and it was a paper that was written in 2011 and published in Springer Plus. My dear students, we all are expecting a lot from you, and we expect papers, the saga that our department, our entire life science faculty is holding, to be continued forward by you. Now, before we land into the paper writing, what will the skills required? First, let us understand ये citation जो बात कर रहे हैं ये है क्या, and how you will improve it. Once you know what you have to do, you will be able to do how it is to be done. You know, for example, if you do not know how the cake tastes like, you will not be able to bake a cake until unless you know that a cake should taste like this. So, as simple as that the 4 C's of citation. First is competence. Impact starts with competence, delivering high quality work. Although there are always exceptions in general shoddy work, it will attract few citations, but high quality, meaningful work, तो citation हमेशा मिलेंगे. अगर आपका काम अच्छा है, तो citation होंगे. दूसरा है collaboration. Now this is very important. Collaboration से मतलब है when you have many co-authors from different realms and they have complementary skills. One is good at one thing, the other one is good at something else. तो जो network create होता है, that also brings lot of citation. Here, very important for your academic reputation. We do not engage any type of questionable practices because our integrity is at question in academics. Then comes communication. It should be able to reach the widest possible people through many alternatives that are available now, including the social media. We will go into those details in another slide. So when we are talking about high impact research papers, let us go step by step. The first step will be finding a high impact research direction. Now, when you have almost reached the 3rd phase of your coursework, you will be entering into your 4th phase. Your titles are already decided. There may be a small tweaking of titles, but not a complete change in your title. So there is a irrelevance of this thing, but the relevance is how you can tweak those small things to bring it to your own benefit. As an example, research begins with a choice on what you want to make progress on. As simple as that. Now, this can center around a few crucial problems that you think, अभी तक तो solve ही नहीं हुआ है, this should be solved. So you have to potentially choose a high impact research direction. That is the foremost thing. As an example, if I choose what is the water quality standard of Mandvi Taluka and Kutch. Now, I myself deep down inside my heart know that ये तो impactful research बनेगा नहीं. But if I'm able to put it in a different direction, where I'm talking about how the ports have modified the water quality standards. Now, the same research can have a high impact when I'm talking about another what we call it in statistics, we call it as I'm missing that word. When we add another thing to that is adding an impact to it. यानी कि आप वही रिसर्च कर रहे हैं, बट एक अलग तरीके से जब उसको आप प्रेजेंट करते हैं, it becomes highly meaningful. Now, this step involves one very important thing. I will want all of you to do this. Yes, Chira. No, it's I have an inverter. Thank you, Ishan. Thank you, Chirag. Am I audible, Ishan?
Yes, ma'am.
Jalpa, I'm audible. Okay, Jalpa. I think the electricity is gone, so some people they got disconnected, but it's good to carry on. One thing that I always feel is that you should always explain your ideas and make them explicit. Now, जब आप अपने ideas को किसी blog post में लिखते हैं, कुछ laureate से discuss करते हैं, किसी को समझाते हैं, जरूरी नहीं है कि वो एक human being हो, तो आप अपने दिमाग में clarity हर बार उसको describe करने में लेके आते हैं. मैं ना ऐसा करना चाहती हूँ या ऐसा करना चाहता हूँ. तो जब आप इसको बार बार रिपीट तो नहीं, बट बार बार जब उसको क्लैरिफाई करके बोलते हो, तो कुछ चीजें आपके दिमाग में अपने आप से क्लियर होने लग जाती है. फॉर एग्जाम्पल, आई वॉन्ट टू गो टू जयपुर. When you are going to say this, I want to go to Jaipur, आप पहले इंस्टेंस में ऐसे बोलोगे, I want to go to Jaipur. But in your next sense, you may be very clear, I want to go to Jaipur by a train. In the third instance, it may be very clear that I want to go to Jaipur by train, which will be running in the night. So you see how clarity is coming. Simple examples, simple ideas, but the way of presentation should reach your heart. Now, very important thing is considering the current and future trends. Science is very slow. And to get ahead, you should focus on trends that will become relevant in about 15 years when you have already collected expertise in the problem. Now, you should have that vision कि 15 साल बाद जब मैं रिसर्च लेके ये आगे पहुंच चुकी होंगी, तो मैं जो आज काम कर रही हूँ, क्या वो रेलेवेंट होगा? सबसे बड़ी बात, I want to bring to the notice of the entire house, publications also take a while. And I will not use the word while, it takes a lot. Because while you write, while you get it published, these are two different horizons. You almost feel like you have crossed a lifetime sometimes. But then the relevance of that research has to stay on for that period and after that period also. Blog post, white papers, research agendas से आपको एक बहुत अच्छा आइडिया आ जाता है कि what's trending. Now the next thing in this step 1 is finding the low hanging fruit. Low hanging fruit का मतलब है you should try to make hopefully comprehensive taxonomies that one can work through in full to avoid selection biases. जैसे कि आपको study करना है as an example the effect of what is the cost benefit analysis of the X product that I'm going to make during my PhD tenure, or maybe any product or any service that I'm going to come up with during my PhD tenure. Now I will try to see मैं सारे सेक्टर्स ऑफ द इकोनॉमी में उसका इफेक्ट देखूंगी या मैं सिर्फ एक ही इकोनॉमी के एक सेक्टर में देखूंगी, जैसे कि फाइनेंशियल इकोनॉमी. दिस आई हैव टू डिसाइड. सो द लो हैंगिंग फ्रूट इज व्हिच सीम्स कि या ये दिस कैन बी डन बाय मी एंड देन आई कैन ग्रेजुअली ऐड ऑन थिंग्स टू डू इट. एंड डोंट डिसमिस योर आइडियाज एज अनथिंकेबल. सबसे बड़ी बात, दैट इज द क्रक्स ऑफ एनी साइंटिस्ट. Wherever you feel कि यार ये मैं क्या सोच रहा हूँ, ये मैं क्या सोच रही हूँ, you are on the right track according to me. Things that people are afraid of thinking about, करना तो बहुत दूर की बात है. The bad news or the good news is they have an elevated chance of offering low hanging fruit for further exploration. Getting the point, I hope?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
okay. So design your research. The next thing is in step 1 itself, design your research को इस तरह से डिजाइन कीजिए कि वो डिसीजन मेकिंग में आपको आप एक पूरी थ्योरी ना निकाल पाए कम से कम, तो एटलीस्ट फ्यूचर में जाके स्टेक होल्डर्स को इन्वॉल्व करने की ताकत तो रखना चाहिए आपका काम, कि ये कुछ बोल रहे हैं इसको सुन तो लेना चाहिए. Why not have a wide policy document out of it? Now comes the second step, choosing the right research topic. इसकी डिटेल्स में बहुत जाना नहीं चाहिए बिकॉज दिस हैज ऑलरेडी बीन डन बाय यू इन कंसाइंस विथ योर ओन गाइड. इट हैज गॉट नॉवेल्टी. मैं ऐसा मान के चल रही हूँ, फिजिबिलिटी है, स्कोप है, करंट ट्रेंड्स के साथ मिलती है. आपने लिटरेचर में गैप्स को ढूंढ के उस टॉपिक को डेफिनेटली चूज किया होगा. अच्छा, नॉवेल्टी जो हम ये बात की है ना पिछली स्लाइड में कि नॉवेल्टी रिगर होना चाहिए, तो नॉवेल्टी क्या होना चाहिए कि आप कुछ नया लेके आ रहे हो. जैसे कि आपने देखा आज की तारीख में सबसे साइटेड पेपर 3 लाख वाला, it has got a very simple technique to identify certain kind of protein in certain kind of XYZ amount in a sample. So उसमें इनोवेटिव मेथडोलॉजी थी. ब्रेक थ्रू फाइंडिंग हो या तो इतनी ब्रेक थ्रू हो कि किसी ने कभी कहा ही नहीं हो और जो आप बात कर रहे हो, ऐसा एटलीस्ट हम सोच के चलें. Let's aim for the moon. Even if we fall among the stars. So next comes the rigor. Rigor यानी the research should employ robust and well documented methodology. ऐसा नहीं अच्छा इतना किया फिर थोड़ा शायद इतना कर ले. No. You have to have a very good comprehensive data analysis. Whenever you are saying that X has got Y in this amount, the Y should come from a lot of comprehensive data जो आपने lab में work किया होगा और उसका बहुत strong theoretical framework रहा होगा. जैसे कि अगर बॉयंसी समझानी है तो बॉयंसी का जो फॉर्मूला है उसके बेसिस पे मैंने अपनी हाइपोथेसिस रखी है और उसका जो लॉ है वो बॉयंसी वाला मैंने उसको पकड़ के रखा हुआ है. क्लैरिटी, आई शुड बी वेरी क्लियर इन माय माइंड दैट आई एम वेरी क्लियर कि आई एम गोइंग टू डू दिस, बट इफ नॉट दिस देन आई हैव वेरी क्लियर प्लान्स B and C आल्सो इन माय हैंड. Broad relevance is very important point because उसमें क्या होता है कि आपका whatever work you are doing, it should also be able to hit the other disciplines also. I sitting in a microbiology department or sitting in a life science department or sitting in department of botany or zoology should be able to talk to my colleagues sitting in any other department of physics or geology and try to understand, is there any interlinkage between what we both are doing. Global challenges, of course, these days only those researches are funded that have got global relevance and have got practical implications. Now, step 3, conducting comprehensive literature review. You have gone through these slides in last lectures. I was just going through your the timetable that was given to me, and I saw that many people have taken those classes. But the only thing is that you should know what are the purpose, sources, and synthesizing kaise karna hai. So a brief, quick look into this. Purpose. A comprehensive literature review is essential for understanding the current state of research. Overview, gaining a broad understanding of the existing knowledge and advancement in your field. Contextualization, placing your research within the context of what has already been studied and discovered. Gaps को identify करना, वो areas पता चलेंगे जो आपने कभी देखे नहीं थे, सोचे नहीं थे. Inconsistencies क्या रह गई, पुराने रिसर्चर्स ने काम करके बीच में छोड़ दिया तो क्या उनकी inconsistency थी. एंड देन डुप्लीकेशन, हो सकता है आपको लग रहा है अपनी लैब में बैठ के मैं तो बहुत नोवेल काम कर रहा है, बट जब आपने देखा तो ऑलरेडी 10 people sitting in 10 different places have already done that work. So you are able to ensure your research questions or hypotheses are original and not a reputation. And सबसे बड़ी बात, रिसोर्स ऑप्टिमाइजेशन, आप अपना समय और एनर्जी दोनों बर्बाद नहीं करते. सोर्सेस क्या है? क्योंकि अब आप रिसर्च एरिना में आ गए हैं और आपने बहुत सारी ऐसी चीजें देख भी ली होंगी अब तक. उसमें से पबमेड के बारे में आपने सुना होगा, गूगल स्कॉलर ऑफ कोर्स सुना होगा, IEEE एक्सप्लोर एंड वेब ऑफ साइंस. These are different sources that we use to find the research papers. इसके अलावा बहुत सारे ऐसे अब AI tools आ गए हैं जिसके थ्रू आप एक्सप्लोर कर सकते हैं and you can focus on your own discipline. Then comes synthesizing. Synthesizing मतलब summarizing your key findings. आपकी major themes क्या रही, उसमें significant studies क्या थी, आपने क्या trend निकाले, pattern निकाले, उसके बाद आपने क्या gaps identify किए, आप उनमें से कितनों को unaddress करके रह गया कि अब you didn't have time, you were not having the resources that you could address those questions. What were the weaknesses that must have been there in your methodologies? क्योंकि मेरे पास X नाम का इंस्ट्रूमेंट नहीं था तो मेरे को Y मेथड से ही करना पड़ा, इसलिए मेरा मैथोलॉजिकल वीकनेस है. या कॉन्फ्लिक्ट एविडेंस क्या रहा है, या आपकी जो फाइंडिंग जो आप एक्सपेक्ट कर रहे थे वो उस तरह के नहीं थे जो दैट यू आर एक्सपेक्टिंग. So this is known as synthesizing that we saw. Until now, if anybody has any questions, this floor is open for questions at any time, not just कि आप एड में ही पूछें. If anybody wants to ask anybody, they want to discuss, and then we'll move forward. Okay, so the slide number 22 with step 4 is visible, right?
Yes, ma'am.
Okay,
Yes,
so designing and conducting research. Now, once you have got the right kind of, direction, you know your research topic, have done the literature review, now you will be designing and conducting your research, the real thing. The research questions should be smart. बहुत सारी जगहों पे ये वर्ड स्मार्ट आएगा, स्पेसिफिक, मेजरेबल, अचीवेबल, रेलेवेंट एंड टाइम बाउंड. स्पेसिफिक मतलब यू शुड नो कि मुझे 5 किलो आटा लाना है, आटा ही लाना है, वो 5 किलो लाना है. अचीवेबल मतलब 5 किलो में उठा पाऊंगा. रेलेवेंट मतलब वो मेरे काम आएगा रोटी बनाने में. एंड टाइम बाउंड कि मुझे 1 दिन में लेके आना है, नहीं तो मैं भूखा रह जाऊंगा. एज सिंपल एज दैट. स्मार्ट, स्पेसिफिक, मेजरेबल, अचीवेबल, रेलेवेंट एंड टाइम बाउंड. मेथोडोलॉजी, डिस्क्राइबिंग द एक्सपेरिमेंटल सेटअप, थ्योरेटिकल फ्रेमवर्क, या फिर जो लोग कंप्यूटेशनल मॉडल्स में हैं जिनका लैब वर्क नहीं होता पर कंप्यूटेशनल वर्क होता है, दे शुड नो द मॉडल्स दैट दे आर गोइंग टू वर्क. Last but not the least and the most important, which I feel that your entire research can go a waste, but if you are not good at data analysis, if you do not know the statistical tools and software. So my request to all of you, as you harbinger into this research field, simultaneously आप लोगों के शायद SPSS के ऊपर शायद कुछ lectures हुए भी हैं. start working on it. Start working on it. See how hypotheses are created. See how those tools work. I have seen students failing miserably because at the end they have not planned their study in a way that statistical tool can take it, and then they are forced to tweak it at that time, which is not a good practice. After you have done everything, आपने आटा ले आए, रोटी पका ली, अब आता है उसको पकाने का समय, वो भी पूरा हो गया. Then it is the eating part, which is known as the writing the manuscript. इसके ऊपर आपका पूरा session होने वाला है. I think Dr. Gaurav will be taking it. How you will be? No, I think I'm not remembering who will be taking, but there is one this paper, this entire session on writing the manuscript. Here we are talking about in brief about those things. The titles, the structure will be having title, abstract, introduction, method, result, discussion, conclusion, reference. अभी एक बात को प्लीज अपने दिमाग में अच्छे से बिठा लीजिए कि जरूरी नहीं है हर पेपर का स्ट्रक्चर ऐसा हो. मेरे कुछ पेपर्स में इंट्रोडक्शन और मेथड्स एक साथ हैं, मेरे कुछ पेपर्स में डिस्कशन एंड कंक्लूजन है ही नहीं, फ्यूचर डायरेक्शंस हैं. सो इट इज नॉट नेसेसरी दैट ऑल पेपर्स विल हैव सच स्ट्रक्चर्स. यू कैन हैव योर ओन स्ट्रक्चरल फॉर्म्स एज पर द रिक्वायरमेंट ऑफ योर पेपर. योर राइटिंग स्टाइल हैज टू बी क्लियर एंड कंसाइज. व्हाट आर द पिटफॉल्स? पहली बात, सामने जो पीयर रिव्यू के लिए बैठे हैं वो सब जानते हैं. दैट इज द मंत्रा. सो अवॉइड ऑल द जार्गन्स, बी श्योर दैट यू आर क्लियर, एंड सबसे बड़ी बात, एडहेयर टू द जनरल गाइडलाइंस. जहां आप उसको सबमिट करने वाले हैं, अगर वो आपसे आपा फॉर्मेट मांग रहा है तो कृपया करके दूसरा कोई फॉर्मेट में उनको ना दें, बिकॉज दिस विल अननेसेसरी डिले द प्रोसेस ऑफ रिव्यू. दिस इज कंटिन्यूड. योर abstract has to be what you call it, the trailer of your movie. You can add visual aids. These days we are seeing that graphical abstracts are there. You should be using those high quality figures and tables instead of getting it from simple tools. Go for high-end tools. Language should be clear. You will see in future when you start studying that this highly cited paper have a simplest English that you can think of. Ethics, proper citation जरूरी है और प्लेगरिज्म से बचना है. एआई को बहुत प्यार से यूज करना है, पर उसकी मेहरबानी इतनी रखनी है कि you have to acknowledge that this part was done by AI. These days many good publication houses are accepting that you will be using AI. They do not deny this fact, but you have to mention the fact. The sixth step is submission and peer review process. This my colleague will be taking for you. You have to choose the best journal, how to prepare manuscript according to that journal's guideline, and then how it will go to peer review. If you want it a blind peer review chahiye aapko ya open peer review chahiye. Now comes the last step, which is known as the post publication strategies, which involves promotion, networking, tracking impact. Now this is, I think, for any publication, this is the most important step, because once you have done all the things, digesting that food is the most important, and post publication strategy is that part. Promotion, social media आपसे बेहतर और कोई नहीं जानता होगा. शायद मैं आपको सिखाऊं उससे पहले आप मुझे सिखाएंगे. What are those platforms? You already know those. Yeah, in scientific community we do follow ResearchGate, LinkedIn, because we rely on them better than Facebook or X, which was earlier Twitter. Tips: create a concise and engaging summary of your paper. Relevant hashtags. आपका research कौन सा है, आपकी field क्या है? Hashtag water, hashtag soil, or maybe hashtag cancer cells. Tag the relevant institution. जो institutions इसमें काम कर रही हैं, if you tag them, then you will have traffic from them as well. And of course, if it is an open access, kindly include a link to the full paper. But if it is not open access, you are under an embargo period where for 1 year you are not supposed to share the entire paper. Kindly do not do that, and this will land you into trouble rather than putting your paper for promotion. Second is academic platforms. मैंने बात की ResearchGate की, Google Scholars, Academia Edu, and many more like Science Direct, etc. इसके अलावा आप अभी से जो शुरू कर सकते हैं, अपने काम को आपने कितना भी किया हुआ इस वक्त, अभी आप शुरुआत करेंगे, लिटरेचर रिव्यू पढ़ेंगे जब, तो go and attend the conferences and workshops. वहाँ आप जब presentations देते हैं, poster या oral, आपकी जो networking होती है, you come to know, oh, these people have also done this work. Let me add this to my work as well. Or maybe let us share the common ideas. What is networking? Networking is engaging with the scientific community. You can do collaborations. You can have, these days we have got this DIS4. DIS4 is discussion forums that work where you have wonderful ideas coming from people who are in your field. Then the professional associations happen. As an example, person X has got an instrument and person Y has got the expertise to work on that instrument. So they will both join the hands through university MOUs or through partnerships that may be personal and not at the level of the organization. Also, you need to utilize the institutional resources. जैसे कि मैंने बताया, MOUs यूनिवर्सिटी प्लेटफॉर्म्स के थ्रू हो सकते हैं. आप अपनी यूनिवर्सिटी में सेमिनार टॉक्स दीजिए, अटेंड कीजिए, वहां जाइए. एंड आउटरीच यानी कि पब्लिक का एंगेजमेंट, मीडिया. जब आप कच्छ में, आपका पेपर पब्लिश हुआ है नेचर में, बट अगर कच्छ के लोगों को नहीं पता, तो दे आर नॉट गोइंग टू रीड योर पेपर इन साइंटिफिक रिपोर्ट्स. ओके, हाँ, यू हैव गॉट. Someday, somewhere, you have to go and tell Kachh Mitra ki, see, this is the paper. Kindly put it in your language, local language, so that people that reside in my area also come to know about my work. Now, once you have done all this, how will you track your impact? You have been happy that I have whatever ma'am told in the entire session, we have done. I will be doing that. But at the end, how will you be tracking your impact? You have got the food, you prepared it, you ate it, you digested it. But agar energy nahi aaye, to how do you know the impact has come? So this energy should come, and that energy comes from the citation databases. They will show you the aina. One is Google Scholar, Web of Science, Scopus. जो metrics काम आते हैं वो है H index. It measures both the productivity and citation impact of your work. Altmetrics, हर एक जर्नल अपने वेबसाइट पे altmetrics देके रखता है. और impact factor, ये ज्यादा जनरल फोकस्ड होता है, बट क्योंकि आपको अपने जर्नल के बारे में पता होता है, तो इट गिव्स अ पोटेंशियल आइडिया ऑफ योर पेपर आल्सो. देन देयर आर सम इंस्टीट्यूशनल टूल्स. हमारे यहाँ पे अनफॉर्चुनेटली डिपॉजिटरी नहीं है, बट देयर आर रिपोजिटरीज वेयर योर इंस्टीट्यूशनल में आप जाके उसको डिपॉजिट कर सकते हैं. एंड लास्ट आई विल फिनिश ऑफ माय प्रेजेंटेशन विद दिस message that dare to be different and critical in research. That is the most important thing that I have learned in my small journey of a researcher, that you have to be you have to think differently, you have to be critical. अच्छा ऐसा हो सकता है, लोग हंसेंगे, so what, let them laugh at your weaknesses, but someday that will be a wonderful result. Okay, so there must be some questions. At least I'm now open for questions, or at least if you have to share your experiences of this day.
I'm sorry if there was some technical glitch from this side due to the power break.
No issues, Ishan. We carried on well.
Okay, ma'am.
This Jalpa will tell us. Jalpa, were you able to listen to all of us what we were saying?
Yes, ma'am. It was nicely explained, ma'am.
Okay. Who's Kajal? Kajal Baldania. He's there.
Yes, ma'am. Yes, ma'am.
Because I can see Aisha is there, Deep, Dhyanesh is there, Drashti, and Gauri Sibaj is there, Jalpa is there, Kajal is there, Lachi Rabari, Meera is there, Meet Parmar. Meet Jala is there, and Parmar also is there. Parth Thakkar and Sanjay Bhuyan is there. Urmi Surani, Vivek Chauhan. Okay, these are our life science and geology students. Okay, anybody has any question as of now? Or else we will close this session. Maybe you can type it in the box also. Usha Parmar. Usha, is this your screen name or this your real name? Okay, Ishan. So I think actually ऐसा लग रहा है all have understood.
Yes, ma'am.
And there are no questions. We should assume all has been understood.
Ma'am, thank you so much for the lecture. It was really insightful. And I'd like to congratulate you and your whole team on behalf of your recent publication in Nature Scientific Reports.
Thank you,
So,
Ishan.
Thank you so much for all the contribution, ma'am. And with your permission, I'd like to end this meeting, ma'am.
Thank you, Ishan. Thank you, everybody. Thank you for patiently listening. Thank you so much.
Thank you, ma'am.